Hello.
Hello. Yes, Dinesh sir.
Yeah, ma'am, it's presenting, ma'am, because I not get it any PPT. That's only I asked.
Uh, uh, we didn't started it, sir.
Okay. I thought you're given the presenting now, so that's only.
No, no,
Okay.
that is only a welcome screen, sir.
Okay, ma'am. I'm on the line. Yeah. Okay. Nice.
Okay, sir.
Why photo anime?
Just one moment. Honey,
Good morning, BV Esther sir. You raised your hand. Anything you want to convey?
Uh, Madam, is this a link? Good morning, madam. Is
Yeah, good
this
morning,
link
sir.
to join?
Sir, can you repeat?
Is this a right link to join the, sessions, madam?
Yes, sir. This one only. For all 6 days, you have to use this link only.
Thank you, sir. For that clarification only, madam. Have a great day. Thank you so much.
Okay, sir. In WhatsApp group also, we have forwarded YouTube link, and the Meet link will also be the same for all 6 days, but YouTube link will be a different. So every day morning, we are going to forward the YouTube link. But for Google Meet, the link will be same for all 6 days.
And one small question: can we have recorded session for practice better after the classes
Sure,
completed?
sir. Sure, sure. We will record, sir.
Yeah. Thank you so much.
Thank you.
Yes, Inosra Garu.
Good morning, sir. Welcome, sir.
Good
Welcome,
morning.
Chankeshwar, sir. Sir.
Yeah, go ahead. Good morning.
Shall we start, sir?
Yeah, you can start.
Yes, sir. Good morning to all the participants. A very warm welcome from the Department of Information Technology, VNR VJIT, to all who are attending this short-term training program on machine learning and deep learning techniques for artificial intelligence problems using Python. And this is series 2 session, so which is going to start from today onwards, 14th to 19th December. And this is a STTP, which intends to conduct faculty trainings through financial assistance from AICTE to enable faculty members in the field of technical education to introspect and learn techniques that can help prepare students for active and successful participants in a knowledge society. Once again, I welcome all the participants, and we appreciate your participation for series 1, and we are looking forward to your participation for series 2 also. Though you are very busy with your schedules, busy with your classwork, invigilations, although you have given your active participation for series 1, we appreciate for that. Now, I consider it a great honor to welcome Dr. B. Channakeshwar Garu, Director for Advancement and Dean Administration, VNR VJIT, to address the participants. Over to you, sir. Channakeshwar, sir. We welcome you and to
Yeah.
address the participants.
Thank you, Revati Garu, for inviting me. Good morning to all of you once again. So on behalf of VNR BJT, on my own behalf, I would like to extend warm welcome to all of you for this second series of STTP program on machine learning and deep learning techniques for artificial intelligence problems using Python. So in this connection, I would like to congratulate the department for organizing this STTP program on the eve of Silver Jubilee celebrations. And at the same time, I also thank all the experts and as well as the delegates who have come forward to participate in this STTP program. Especially, I think today everybody is talking about AI, machine learning, and deep learning only. So that is the reason that's why we have started 4 UG programs in the area of data science, AI, machine learning, IoT, and cyber security during this year. So as for VNR VJIT is concerned, this college was established in the year 1995 by V. Vijnana Jyoti Society. So this college offers 13 UG programs with an intake of 1500 and 13 PG programs with an intake of 234. Altogether, we are offering 26 programs. And we have nearly 400 faculty members, out of which 140 faculty members are having PhD qualification. Another 180 faculty members are pursuing PhD in various disciplines. And we have 160 non-teaching staff, both technical and non-technical staff that are available, in addition to class 4 staff, 100 people. But as for VNR BJT is concerned, this year is very, very important for all of us actually, because we have successfully completed its journey 25 years. And this year we are going to celebrate Silver Jubilee celebrations. So on the eve of Silver Jubilee celebrations, we have decided to conduct a number of training programs to our faculty and outside faculty also, so that definitely they can acquire whatever the skills that are required by the industry 4.0. And this institute is recognized under section 2F and 12B of UGC Act 1956. The institution is accorded autonomous status by UGC for 6 years in 2012, and extension of autonomous status is accorded for 10 more years in the year 2018. This institution is accredited by NAC with A++ grade. This is the only institution accredited A++ grade with a CGPA of 3.73 out of 4 scale in cycle 2 in 2018. And 7 UG programs also accredited by National Board of Accreditation, out of which 1 program got 5 years, another all 6 programs got 3 years accreditation, third time. And this college is also recognized by UGC as a college with potential for excellence, that is CPE status given by UGC in year 2016 itself. And this college also got AICT Research Center recognition, and we got even 10 NDF, National Doctor Fellowship programs offered at VNR BJT. In addition to that, 5 departments are recognized by JNTU as research centers, and already 5 people are allotted by JNTU as full-time PhD scholars. So put together, we have 15 PhD scholars that are available at VNR BJT in addition to UG and PG programs. And this college is also ISO certified institution, and QS iGauge awarded Diamond College rating, and even E-Lead certificate also we got it actually. And according to NRF ranking, we got 127th rank at all India level, and even in the overall ranking also we got between 151 to 200 ranking. Even Atal Incubation ranking also we got it between the 6th to 25th band. So that way I think these are some of the credentials of this college. And as for the department is concerned, actually, especially there are I think few quite good research scholars that are available in the department of IT and as well the computer science, and especially this department is doing extremely good job, and they're publishing good papers in good journals also. So that way I think they are very active, especially D. Srinivas Rao and Madhu and Radha Krishna Garu and Rajesh Mangatara Madam, Suresh Reddy, all these people, they are doing extremely good job. In addition to that, I think all young people also, they are pursuing PhD in the area of artificial intelligence, machine learning and deep learning and IoT areas. So, but as for, I think you're all aware about that education, I think is very, very important, and it is a continuous learning process. Education is the passport to the future, but tomorrow belongs to those who prepare for it today itself. So that way, unless you acquire whatever the skills that are required by the industry 4.0, I think it is very, very difficult to sustain in the field of computer science and information technology field, because today technology, tomorrow outdated technology. So how fast it is changing, at what speed it is changing the technology, I think you're all aware about that. Please try to acquire all the skills that are required by the industry and be ready for facing the challenges. Even though, so there are quite number of applications that are there in artificial intelligence, like I think you're all aware that e-commerce. I think during this pandemic time, I think majority people, I think they're using only AI and deep learning and machine learning techniques or various algorithms that are available to give the better solution. AI in e-commerce, AI to improve the workplace communication and human resource management, AI in healthcare and intelligent cyber security, AI in logistics supply chain and sports betting industry, and especially retail business also. I think majority people, they are using AI. Agriculture sector. So these are some of the areas I think everybody I think are familiar with all these new algorithms that are available, so that by using all those new algorithms, definitely we can produce effective and good solution. So that way, I think each one of you please try to, because the Python is very, very important tool. Each one of you, I think you're all aware about that. I think everybody is switching over to Python. Previously, we used to use a Java, and now I think everybody is using Python. So each one of you, please try to acquire all the skills that are required to handle the problems facing by the society. I request all of you, please try to be active and take part in this particular workshop and acquire the new knowledge and try to disseminate that knowledge to your fellow friends. I wish you all good luck. Thank you once again for sparing your valuable time. All the best.
Yeah.
Sir.
Thank you. Thank you, sir. It will be a great pleasure for us to listen to you again, sir. And your words are indeed. Thank you. Thank you, sir. Chennakeshwar, sir. Thank you once again. Now, it will be a privilege for me to invite Dr. G. Suresh Reddy Garu, Head of the Department, Information Technology. We welcome you to this STTP, sir. And I request Dr. G. Suresh Reddy Garu to share his views and bless us with his kind words. Over to you, sir.
Thank you, Revati. Yeah. At the outset, I congratulate all the participants who have been registered for this STTP on machine learning and deep learning techniques for artificial intelligence problems using Python. Yeah, I congratulate the coordinator, Dr. D. Srinivasarao Garu, and co-coordinator D. Revati, and all the supporting staff who are helping us with the live streaming and all those things. On behalf of the management, I also thank the AICT for sponsoring this STTP. Two series, this one, the last month we have conducted in the month of November 15th through 21st, and again we are conducting series 2 from 14th to 19th. So let me give a brief introduction of the department. Department of IT has been established in the year 1997 with an intake of 60. Later in 2017, it has been increased to 180. We also offer a PG program in CNIS, Computer Networks and Information Security, which started in 2013 year with an intake of 18. So overall, the faculty on rolls are 41, 2 professors, 5 associate professors, 1 senior assistant professor, and 33 assistant professors. So coming back to the publications of the department, in the last 5 years, we have published around 219 publications. Out of that, 172 are Scopus, SCI, and Web of Science, this one. So the R&D related works which we have carried out in the department are worth of 45 lakhs, we have completed, and around 17.51 ongoing projects are done, and we have applied more than 3 crores projects to various organizations in the last year. So this is about the brief, and coming back to the students' performance, the academic results are 98% in the IT department, and overall 100% placements. The last time this year, it's almost going on with 31.50 lakhs package as the highest from Amazon software engineer designation, and a few other students have selected for 28 lakhs, 19 lakhs, 18 lakhs, 14 lakhs, like ons. The average package what we do here is 8 lakhs. So this is how the department is working, and it is very active. I congratulate all my colleagues who have been supporting for me to conduct these kind of SCTPs or FDPs or webinars. We have conducted a lot in this pandemic time from March to June or July. We have conducted a lot of FDPs and webinars, etc. So I congratulate once again for conducting this STTP. The department is also accredited thrice in NBA, so that is most important. And I think the credentials of the institute have been given by the our beloved director, and I thank our director and principal for giving us this opportunity for conducting this STP. Thank you, Revati.
Thank you, sir. Thank you so much, sir, for briefing about the department. And thank you, sir, for enlightening us with your kind words. Thank you once again, sir. Suresh Reddy, sir. Thank you. So now, if you have ever wondered who can learn this deep learning and machine learning techniques, the answer is yes, you can. And if you have asked yourself where to learn machine learning and deep learning techniques, here is your answer, this HTTP. And it teaches you, among other things, all the techniques for artificial intelligence problems using Python. Now, I would like to request our coordinator, Dr. D. Srinivasrao Garu, Associate Professor, IT Department, to address the participants with his words. Over to you, sir.
Yeah, good morning, one and all. This is great privilege to introduce you all for the Series 2 HTTP program. Series 1 is conducted in the month of November during 16th to 21st. Is focused on machine learning algorithms for real-time applications. Now Series 2 is going to be focused on deep learning algorithms helpful to develop the artificial intelligence applications or to solve the problems existing in various domains. On the context, I should thankful to the AICT for sponsoring the grant to conduct this online HTTP program, and Principal Sir, Director Sir for guiding us, and beloved HOD Dr. G. Suresh Reddy Garu for leading us to conduct these type of events and disseminating the knowledge to the required people at right time. Prepare to explore before nowhere. The quotation or the slogan which gives you the strength to commit for learning. Based on the title given to the HTTP, in Series 1, we have arranged the sessions from the various speakers exercised from esteemed organizations, includes IITs, NITs, university colleges, and private colleges, and industry also. We have exercised to prepare the sequence of topics that gives you the more insights and scope to learn on the particular HTTP titled Machine Learning and Deep Learning. We have prepared the schedule by taking the inputs from the speakers of various esteemed institutes and prepared in a sequential manner to gives you the maximum outcome to the listeners, the participants which are most active and which is the fuel for any program to be succeed. So a great welcome to all the participants for registering this particular event. Though you are busy with your academic works and your professional activities, we have collected the registration forms from nearly 450 faculty, includes research scholars, includes the industry people, and all of them are accepted and sent the positive mail to welcoming them to participate in this particular event. As it is focusing on the deep learning algorithms for the applications, which includes the data science domain, artificial intelligence domain, IoT domain. By preparing the sequence of events, starts with the introduction of deep learning and giving the introduction on neural networks, which is the prerequisite to learn the deep learning, and exploring applications of deep learning to see the importance of deep learning, and started exploring various applications which needs the deep learning at the platform, includes face recognition, natural language processing, sentiment analysis, disease identification, and the role of deep learning for video processing, importance of the deep learning for speech processing, and usage of the advanced technique of deep learning titled capsule networks, that also gives you the insights of combining or reusage of the existing techniques named transfer learning, and also trying to give you the practical exposure for recommender system and focusing on the important application of AI, also called deep learning for autonomous vehicle. And we are ready to give the presentations on generative models for computer vision with the practical implementation by acquiring the knowledge while developing the applications in the academic labs of IIT Ropar. And we are ready to give you the scope of research in AI, ML, and DL that helps you in your career for successful progress. We have eminent speakers from NIT Patna, NIT Goa, NIT Jaipur, NIT Rourkela, IIT Ropar, and we have the speaker from industry also. So we prepared this particular event to give you the better inputs to all the participants who are seeking to get something from us. I promise you, with the regularity of your attending and listening to the sessions, you will get the important concepts of deep learning that can be utilized in various applications of engineering domain. I should thankful to everyone who helps me to conduct this event in a successful manner, with the co-coordinator, the co-faculty, the networking team, and all the stakeholders who help me either directly or indirectly. It's a great pleasure to welcome you all for this particular event to be started from today, and it will be concluded with Saturday. Based on the AICT norms, the participant need to have minimum 80% of attendance and 60% of performance in the test provided, the minimum criteria to issue the certificate. So be regular and be patient and be an active learner to fulfill your wishes under our efforts. Thank you, one and all.
Thank you, sir. Thank you so much, sir. I think it surely helps all the participants to understand the objective of this training program, this STTP. Thank you, sir. And I thank B. Chennakeshwar Garu, Director for Advancement and Dean Administration, and Dr. G. Suresh Reddy Garu, Head of the Department IT, and Dr. D. Srinivasrao Garu, Associate Professor and Coordinator for this STTP, to share their views on this STTP and to address all the participants. Thank you once again. Now, next session is going to start about the topic machine learning versus deep learning, and this talk will be given by Dr. D. Srinivasrao Garu. So this talk will start around 11 o'clock. So we'll take a short break for 15 minutes. So we'll start the session at 11 to 11:15. So we'll take a short break. So next talk will start at 11:15 now. Yeah, dear participants, a session will start exactly at 11 o'clock. Topic is machine learning versus deep learning. Dr. Srinivas Rao sir will take the session. So please take a short break for 15 minutes. We'll start at 11 o'clock exactly. And for regarding attendance and feedback forms, so attendance and feedback form is same. We are going to forward the feedback form and attendance form around 1 o'clock. After the session, it will be forwarded only in the Meet and YouTube. We are not going to forward these links in the WhatsApp group. So attendance form link will be posted only in the Meet and YouTube after 1 o'clock, and for afternoon session after 3:30 we are going to post it. So to issue e-certificate, definitely please sure you should participate minimum of 9 sessions out of 12. Okay, so to get 80% of the attendance, and on the last day of this STTP, that is on Saturday afternoon, we are going to conduct one online assessment exam. So in that exam, you should have to have minimum 60% score is mandatory. Okay, to qualify, 60% score is mandatory. So those are the criteria for this STTP, 80% attendance and 60% score in the test. So out of 12 sessions, you should have the attendance of 9 sessions. Links will be forwarded after 1 o'clock and after 3:30 in Meet and YouTube. We'll take a break for 15 minutes and session will start at 11 o'clock. Thank you.
Ma'am, at what time the session will start? Hello?
At 11 o'clock, they said.
At 11? Okay. 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 Thank you, ma'am.
ఇంటర్వ్యూస్ ప్లాన్ 17వ తారీఖు ఎగ్జామ్స్ ఉన్నాయి. కాలేజీలో 300 అట్లా పాయింట్ కాకుండా డైరెక్ట్ కేబుల్ లాంటి డైరెక్ట్ గా కేఆర్లో కరెంట్ పోతే నెట్ రాదు, టవర్ ఫెయిల్ అయితే నెట్ రాదు అంతే. అంతేగాని ఇప్పుడు మధ్యలో పాయింట్స్ ఉంటాయి, ఆ పాయింట్ దగ్గర కరెంట్ పోతే నెట్ రాదు. అవును సార్, అవును. ఇంటి నుంచి 20 హౌసెస్ వెళ్తుంది బాలాజీ బ్లాక్ అండి. అదే నేను ఆఫ్ చేస్తే అందరు కాకపోతే రోజు ఆఫ్ చేస్తారా? అప్ప ఆడ సార్ ఒక్క నిమిషం ఆఫ్ చేశాక ఫోన్స్ వస్తావు ఆఫ్. ఇప్పుడు చాలా మందికి వర్క్ ఫ్రమ్ హోమ్ కదా సార్, ఎక్కువ ఫోన్ చేస్తారు. అట్లా ఎగ్జామ్ లో ఇంటరప్ట్ అయితే ఎగ్జామ్ కంటిన్యూ కాదు. స్టూడెంట్ లైఫ్ మాకు వచ్చేది ఇక్కడ సార్ బాలాజీ ప్రాంతం నుంచి బ్రహ్మంగర్స్ వస్తుంది పాయింట్, అక్కడ నుంచి మా ఇంటికి పెట్టినాడు. అక్కడ స్విచెస్ ఉన్నాయి, మా ఇంటి స్విచెస్ పెట్టినాడు. అక్కడ ఆఫ్ అయితే మేము ఆఫ్ చేసి వీళ్ళ మీద వాళ్ళకి వీళ్ళను పని చేయించారు. రోజు ఒక టాపిక్ ను వచ్చి చెప్తాను. మీరు చెప్పండి సార్.
నేను చెప్తారా మసాజ్ ఎవరు
చెప్తే
అది వచ్చిన చెప్పలే వాళ్ళు చెప్పాల్సింది అంత 5 మంది వాళ్ళు చెప్పుకోవాల్సింది సార్. మిగతా ఎవరు రాదు సార్ కాలేజ్ కడతామని ఆల్రెడీ అప్లై చేసి చూసాం సార్.
ఎలా రాదు సార్ ఎగ్జామ్స్? సిలబస్ ఎక్కువగా ఉంటాయి, కాన్సెప్ట్స్ ఎక్కువగా ఉంటాయి. లాస్ట్ ఇయర్ ఫస్ట్ పేపర్ ముందు పెట్టుకోవాలి, సిలబస్ ముందు పెట్టుకోవాలి. వీళ్ళ ఫ్రెండ్స్ ఉన్నారు సార్ ఆర్మీలో, జనవరి 1st వీక్ ఉంటాయని చెప్పారంట ఎగ్జామ్స్. స్టూడెంట్స్ ఎక్కువ. చేయడానికి
Dear participants, welcome back to the session. Now, the talk is on machine learning versus deep learning. So before hand over this session to the speaker, let me introduce our resource person for today's STTP, Dr. D. Srinivasrao sir. Dr. D. Srinivasrao, Associate Professor in the Department of IT, VNR VJIT, holds PhD in 2007 in the specialization of CSE from JNTU Kakinada and MTech from JNTU Hyderabad and BTech from Nagarjuna University. He worked as a research scholar in Everest Laboratory at University of Udine, Italy, as part of MOU between JNTU Hyderabad and University of Udine, Italy. Dr. Srinivasrao Garu has 17 years of teaching and 14 years of research experience in parallel with teaching experience. 25 papers are published in various journals and conferences. 10 papers are indexed in Scopus indexed journals and 5 papers are indexed in Web of Science. He is a guest editor for the journal titled Machine Learning in Data Mining, Data Analysis, and Data Science. He is also a reviewer for Journal of Computer Science, European Journal of Remote Sensing, International Journal of Image and Data Fusion. He delivered guest lectures, expert and invited talks in various FDPs, STTPs. His basic research interests are artificial intelligence, computer vision, machine learning, and deep learning. He guided 20 undergraduate projects and 5 postgraduate projects. He also successfully completed the research project titled Image Fusion using Fuzzy and Neurofuzzy Logic from AICTE RPS. Currently, he is working on the project funded by JNTU Hyderabad on TechWhip 3. And he is also a life member in IEEE, ACM, CSI, and ISTE. And he also obtained the 3-month advanced certificate in artificial intelligence and machine learning from IIIT Hyderabad. With this long list of achievements, now I would like to invite Dr. D. Srinivasrao Garu to take over this session. Sir, please continue, sir.
Yeah. Thank you for your nice introduction. Yeah. As the session is scheduled on deep learning and its algorithms in real-time applications, I need to connect the series 1, which is mainly focused on machine learning algorithms. Now the series 2 is focused on deep learning usages in application development or in solving the AI problems. In order to interpret the concept in a easy manner, the diagram taken comprises association among artificial intelligence is the broader area which have machine learning as the subset, is the concept of learning from experience, will have the deep learning as the subset. When you combine machine learning, deep learning, and other skills, we will develop the artificial intelligence system that could be able to provide the solutions equivalent to human being who are named expert in the domain. So the artificial intelligence is the effort required to prepare the system that make the things better like human expert. But artificial intelligence development is not a simple issue. It is the integration of various concepts, various technologies, and various algorithms to be integrated. Here I am trying to give you the association among these three, and I will try to give you the correlation between machine learning and deep learning, especially as they are the subcomponents of artificial intelligence. Artificial intelligence is the broader word. It's a great thing that performs the excellent decision making, which are equivalent to the outcomes given by the expert in the specific domain. Artificial intelligence, machine learning, and deep learning are very frequently listening in these days, but these are not new ones. They are started at 1950s with the label artificial intelligence. That's just the excitement till 80s. In 80s, the usage of machine learning came into existence that begins to flourish. The outcome obtained from that particular execution happened till 2010. The deep learning commencement started at the same time, and its breakthroughs the drive of AI boom because of specific reasons. Those reasons are listed like the journey of AI, ML, DL takes place with the inception of the great person named Alan Turing as a mathematician and a cryptographer who decipher the given concept, and he tried to build the system and to test the same system by comparing the outcomes obtained from the system developed and the response given by the human expert. That type of system is built and tested. That is why the concept named Alan Turing. Based on the efforts made by Alan Turing, the concepts of AI and implementations of AI started then with this particular slogan given, that is named, it is a general AI with the effort of can computers could possess the same characteristic of human intelligence, including reasoning, interacting, and thinking like what we do. The answer was a no, because the systems or the computers can do the things based on the instructions given by us to do so. The computers are there to do the activities based on programs given by us to perform a particular task. That's all. They don't have the common sense. They don't have the flexibility. They don't have the ability of interacting. They don't have the property of compromising when it is required, adjusting when it is required. In terms of incompleteness, uncertainty, and ambiguity. If you have in this environment, without having adjustment, flexibility, and interacting with the world, no computer solves the problem perfectly or precisely. Therefore, we have to focus on narrow AI, the technology that can accomplish the specific tasks, such as playing the chess, recommending your next what wish to do, identifying the spam mails from the normal one. All of these exhibit the parts of human intelligence. But how do they work? How do they work? The answer for this is the machine learning. If you want to have the capability of reasoning, interacting, and thinking, the answer is that should be a machine learning system rather than the computer system. You are trying to associate these three concepts in the form of the figure shown, as you can see on the image, having three concentric circles. The DL is subset of ML, which is also subset of AI. So what's that? How they are related? AI is all encompassing concept that initially erupted, blown, then followed by ML that grow later, that thrive later, the ML that thrive later, and lastly, DL, deep learning, that is promising to progress, that progressing the advances of AI to another level. So AI will tells you the problem to be solved. ML will identify the algorithm to learn from experience, and if you want to be more precise in an outcome, then the deep learning is required, as deep learning is simulating the functionality of the brain. It is simulating the capabilities of human by identifying the patterns, by identifying the complex issues, and coming out the labeling or coming with the conclusions. As human beings have the great capabilities of instant responding, instant interpretation, dynamic in nature, intelligence, thinking, organization, knowledge management, reasoning. These are the great capabilities of human being. And the same capabilities I need with the computer system. I need to be feed all those concepts, all those capabilities into the computing device. That is the objective. So I need to develop the system called AI system that should have the capabilities of human expert, as I can't place human expert at all the places, as human experts are very expensive and very scarce. So what should I do? Instead of searching for the human expert required in my domain, in my profession, I need to develop the system, AI system, that could able to do the things as human expert will do in my contemporary applications. AI is efforts to build a system that do the things which can be done by the human expert. But in detail classification of AI, they are divided into narrow AI, general AI, and active AI, as it is the main superset for ML. ML is the superset for DL, deep learning. What narrow AI? A narrow AI is said to be narrow when the machine can perform a specific task better than human. Then how it should be appreciated? The current research of AI is here now. So it is focusing on a particular application, a particular context, where my system could be able to do better than human being, better than human expert. But the scope of applications are very limited. That is why narrow AI. The best examples of narrow AI are the Siri responding to your queries, autopilot in the airplane that reduces the burdens of the pilot, or reduces the tensions and the actions and responsibilities, and to make the driving is more comfort. The chatbots that gives you the precise response to the queries can be used in almost all domains, and self-driving cars that reduces the burdens of the driver. This comes under the narrow AI, whose performance is better than the human being. As the usage of this particular AI is limited, it is named narrow. The systems are not conscious, they're not sentiment, they are driven by emotions as humans are. They use information from a specific data set. The data set is applicable for the particular context. Maybe the drug discovery or drug prediction or disease identification or a language translation or a sentiment analysis or a video processing or a speech recognition, whatever it may be, that is limited to the context and the data set associated with that, and not for many tasks that is outside of the task given. That is why it is narrow AI. Afterwards, a general AI, the AI that reaches the general state when it can perform any intellectual task, not only task one is specified. I have the largest scope. I have in the world where the scope is large, and I am not limiting the domains or problems to be solved. No more constraints as my world is open. So I need a broader area, a broader solution is general AI with the same accuracy as human would do. My general intelligence is referred as strong AI. It is a concept which machines exhibit human intelligence. In this, the machines have the ability to learn, to understand the world, and act in a way that is indistinguishable from a human being. That is the objective of building AI. I should not differentiate response from human being and response from AI system. If I am not able to differentiate response obtained from these two, I succeed to build the AI system. That is the objective of building AI with the help of machine learning and deep learning algorithms. That's a great effort is required, but it's not easy to do so as we wish. The general AI does not currently exist, but has been used in many scientific movies, Hollywood movies. Almost all Hollywood movies comes under general AI, where they are trying to build the systems that exhibits outcomes which are far better than human experts. In these movies, they are developing the systems in which the humans interact with the machines. All of you know the visualizations, outcomes available in the movies. They're able to interact with the machines that are conscious, that are driven by emotions, and they are self-aware. In the previous one, in the general one, we can't see all these capabilities, but the systems developed in the Hollywood movies, they are conscious, they're driven by the emotions, and they're self-aware. The same capabilities I need to have for my system that might be used in the AI domain, data science domain, or auto manufacturing, or automobile company, or a 3D printing, or IoT. In terms of smart agriculture, in any area, I should have the system with these capabilities so that the life is very comfort, very precise, and very confidence. What is this expensive one to do so? In terms of development, in terms of usage, comes under maintenance stage. Using strong AI, we can have the ability to build the machines that can think, that can strategize, and perform multiple tasks under uncertain conditions. That is the important factor to be considered. Uncertain conditions. Conditions are not certain. Includes incomplete data, ambiguity data, and uncertain. Uncertain, ambiguity, incomplete. These are the barriers to build a great AI system for 100% precise. But still, I am looking for the better outcome from the uncertain environment. That is the great subject in the computer science world. It is named soft computing techniques. When you have everything you want, then you can develop the best solution. It is called hard computing. But always don't expect the better things in the life, in the context. Sometimes you will be with incomplete, imprecise, and uncertain, but still you have to produce the solutions with precise, with exactness. So what you will do? The only option available is soft computing. It is the part of the, again, a great broader domain, artificial intelligence. They can integrate their prior knowledge in the decision making to come up with innovative, creative, and unconventional solution. What solution here I am developing? I'm seeking to develop is unconventional. I'm not following the traditional, I'm not following the existing because the new problems are coming. I'm going to step into new environment. So new environment, new problems, new features are producing. Then how can I compromise with the conventional, traditional, old solutions? I should be with unconventional, innovative, creative solutions because no two problems are same. So no two requirements are same. No two data sets are same. No two users are coming with. So as domain changes, need changes, data set changes, feature changes, how should I give same solution for two different problems? I should not. I should give two innovative, two creative solutions to two different problems. I'm not trying to convince the user to give the same solution to the same problem. One more context of that particular situation is artificial superintelligence. I'm sure everyone remember the Arnold Schwarzenegger's the movie The Terminator, which is the best example for artificial superintelligence, where machines can cognize, recognize, the perceive, the superseded human, the replacing human intelligence in all aspects. In that particular movie, the Terminator perceives everything and replaces the human intelligence to solve the given solutions. It solves the problems provided and coming with the better outcomes and better jobs which are given to that particular mission. The artificial superintelligence is a hypothetical AI. The theorem is developed, idea is proposed, and not sure how much it goes to exhibit, how much solutions are given, and what is the accuracy of the solution. It will be capable of exhibiting intelligence that surpasses that of the brightest human, means expert. So my hypothetical, my proposal, my methodology is to deliver the solution which is equivalent to the expert solutions. In this type of AI, apart from having multi-faced intelligence of human beings, machines will have greater problem solving and decision making capabilities that will be far superior than common human beings. That is why the super intelligence. So, which are far better than the general intelligence. It's type of AI that will have a great impact on the humanity and may lead to extinction of the human race from the planet. So, if you want to be more comfort, if you want to be more precise, if you want to be more satisfaction in your life, either in personal or in professional, we are seeking to have AI with super quality, artificial super intelligence. We are seeking these type of missions in all our personal and professional life for more comfort and more satisfaction and more preciseness. So if you want to have a system with those capabilities, we will start with this first subset of AI is the machine learning. It is the subset of AI, and the name implied machine have the capability of learning. Normally, the human being have the capability of learning because of the specific capabilities the human being is having. They are reasoning, thinking, learning, the perceiveness, understanding, the flexibility, and common sense reasoning, and compatible with the uncertain conditions. Very faster. The human being is faster in learning, faster in interacting, faster in perceiveness than anything. The same capabilities I want to provide to the system. So how it is possible? Until system doesn't have learning capability, it is not possible to have. So the AI that uses the statistical learning algorithms to build the systems that have the ability to automatically learn and improve from experiences without being explicitly programmed. So the machine is ready to learn based on experience obtained from the problem solving process, which are done in the past. So based on problems solved by the machine, they are learning from every problem solving process, and that is the experience gaining from solving process, and those experiences are refined and they helps to the machine to handle the new problems and to give the solutions in more accurate. That is the machine learning. Most of us use machine learning in our day-to-day life when use the services like recommendation system on Netflix based on your habits, based on your movies watched past, based on videos watched till now in various platforms. YouTube and Spotify is the platform where the music and the interested videos are recommended based on your past. Search engines like Google, what documents you searched so far, what audios you searched so far, watch videos, watch content you searched so far in great search engines includes Google and Yahoo. And also voice assistants that also recommends you based on your past includes Google Home and Amazon Alexa. These are the best devices. These are having the capabilities of machine learning. They're learning from every context, learning from every problem solving, learning from every aspect which you have executed or utilized so far. In machine learning, we train the algorithm by providing with lot of data and allowing it to learn from that particular data and more about the processed information. So you are giving the data to the algorithm. The algorithm need to learn from the data given, and it is ready to take the new queries and to give the more accurate answers. That is the sequence involved in any machine learning. Like if I have the real-time context of fruits having attributes 2, and I have to determine the third attribute. The two old attributes I have is the fruit weight in grams and fruit texture, either rough or smooth. These are the two variables x1, x2 to define the y1, the dependent variable. So independent variables are weight and texture, and dependent variable is type of fruit. If the weight is 155, texture is rough, labeled orange. It is known, it is the fact. 180 grams, rough texture, orange. 135 grams, smooth texture, in real time, it is apple. It is active, actually it is an apple. 110 weight gram, smooth texture, apple. Now, I am going to be give the query by giving two values for two variables, weight 120 grams, texture is smooth. Could you tell me the name of the fruit? So this is the data given to the algorithm, and the algorithm is learned from this data, and now it is ready to give the answer to the query. This is the data given, and algorithm is learned, now ready to give the precise answer to the question given. So if 120 weight of and smooth texture, could you tell me the name of the fruit? As you can see the table, you have to do that. This is the best machine learning. I will give 150 weight gram and rough texture. What is the name of the fruit? So that is the new query to be answered. If my algorithm learned from the data, my algorithm should give the precise answer. So the machine algorithm can be developed to try to identify whether the fruit is orange or an apple. If my algorithm is properly learned, after algorithm is fed with the training data, this is the training data, it will learn the differing characteristics between an orange and an apple. So if it is learned and able to differentiate orange with apple, algorithm is ready to take the queries, new inputs to give the proper output to that new input. Therefore, if provided with the data of weight and texture, it can predict accurate the type of fruit with those characteristics given in the form of independent values to the variables. What are the best characteristics a machine learning algorithm should have? It has ability to generalize and not too much. So when you have too much, it goes for overfitting. Generalize in the sense that the scope of machine learning is large. So the machine algorithm which I have developed can be used in great many contexts. That is the generalization. The algorithm developed is not only specific to one context or two concepts, it should be bit broader, bit generalized, so that the usage of algorithm is very broader by doing the small modifications, few adjustments. The algorithm is usage is very high. It should be robust to secure and to prevent unauthorizations and other barriers to perform the best performance. It should be reliable, and where I can depend on the algorithm for 100%. Further, algorithm should be more reliable in the context of incompleteness, uncertainty, and ambiguity in nature. It learned models of high quality. The quality obtained from the algorithm decision is appreciated. It should be scalable and efficient in nature. It should be explicative, and where the outcome can be received with the more satisfaction. It should be a deterministic. The deterministic is the nation of giving the proper conclusions. Based on the type of learning happens, the machine learning is broadly classified into supervised, unsupervised, reinforcement. I can also say semi-supervised, which is the combination of supervised and unsupervised. As the name implied, supervisor means guide, means mentor, who are monitoring your learning, and they are telling this is true, this is false. So learning happens with guide, with mentor, with the teacher. That is called supervisor learning. Learning happens without mentor, without guide, is called unsupervised. Learning partially happens with mentor and partially happens without mentor. It is called semi-supervised. Learning happens based on rewards. It is called reinforcement. So in supervised learning, we have input variables x and an output variable y. Like weight of the fruit and texture of the fruit is input variable. Output variable is type of the fruit, orange or apple. We can use algorithm to learn the mapping from input to output. Inputs are the attributes of the particular context. Here, I will take the mixed data, raw data, initial data, and this data will have attributes are called features. Features are basic building names, basic building attributes to perform either prediction or classification. Machine learning algorithm either do the prediction or do the classification. Prediction means giving the value. Tomorrow temperature minimum should be 20, maximum should be 30 in the Hyderabad city. Tomorrow, the active cases in the Telangana state will be 500. Death will be less than 10. This is prediction. Classification means labeling. Is labeling. The pass the student, fail the student. This is an apple. This is an orange. This is a car. This is a pen. That labeling is given. It is called a classification. Machine learning algorithm can be used either for prediction or for classification. In the supervised learning, based on the data taken, attributes are identified, and from those attributes, the algorithm, here we have the supervisor. What supervisor do? If it is the weight, if it is the texture, this is apple. This is the weight, this is the texture, this is banana. This is the weight, this is the texture, this is mango. Like this, I am giving inputs and outputs corresponding to. Based on this mapping is done, and the same data is fed to the algorithm. My algorithm will learn from the data which is fed to the algorithm. Based on that feeding, algorithm is learned something. What it learned is based on the weight of the fruit, size of the fruit, texture of the fruit, it could able to identify what is the name of the fruit. That is the learning happens. Just like you are giving the learning capability to the kid or infant in terms of giving the pronunciation for alphabets or number reading 0 to 9. How you are feeding to the kid, the same thing happens. If kid gives wrong pronunciation or wrong reading of the numbers, we are there to correct him or her in the form of supervisor. So learning happens with supervisor, with mentor, with guide. It is called supervised learning. So once algorithm is learned, the new data is given to the algorithm, and my algorithm will say, yes, when I mixed red dot, green and blue, once this process happens, attributes identified, and if attribute 1, attribute 2, or x1, x2, then y1 is. In the second context, x1, if x1 and x2, then y2. Third one, if x3 and y3 and x3, the third record of 2 attributes, then y3 is labeled, it is mapped. So based on this mix of input data, once the algorithm is learned, and for that this classification is happened, the red dots, the green dot and blue dot. So whenever the new input is given, either a red or green or blue, that is able to identify and is able to differentiate with others, as it happens in the form of a supervisor. In supervised algorithm, it knows set of input data set and responses to the data, either in regression model or in classification model. A learning algorithm that trains the model to generate a prediction for the response, like temperature, the value for the active cases, or the package for the performance of the student, could be anything. It could be predicted. Prediction for the response to the data are the test data sets. Test data set means the new data set is given in the form of a query. In this example, the classifier will be trained to detect if the image is a bicycle, boat, car, or plane. So what it should be done, how it should be done, there are sequence of steps. Collect the data, train the classifier, collect the data, train the classifier based on attributes like, in the form of fruit, attributes like weight, texture, shape, and the, if you take, and the output is what type of fruit it is, orange, apple, banana, mango, etc. So the first step is necessary. Choosing the right data will make the algorithm success. The right data means the real data, the ground truth data, not synthetic data, not the data obtained from assumption. It is not obtained from assumption. It's not taken based on trial and error. Take the ground truth data, real data, not entered as you wish, not fabricated. Whenever the rate of data is real, then the percentage of outcome in the form of accuracy will be defined. The data you choose to train the model is called a feature. In the object example, features are the pixels of image. Example, I have taken 28 by 28 size image and arranged in the column wise 784 columns. Each picture has transformed into a feature vector. Based on feature vector, the label tells the computer what object is in the image. See, this is the data given. I have given image of bicycle, the boat, car, and a plane. This is the data given. Images are given. When they are converted into pixel resolutions, they will be having like this. They will be having like this. 28 by 24, 784 columns are there. Based on the resolution of the image, they are placed in the physical concatenation. This is called feature vector. If this is the feature vector, it is labeled bicycle. If feature vector is like this, this is boat. If it is like this, this is car. If it is feature vector and it is labeled plane, that is the data given to the algorithm. Algorithm will learn from this. If the feature vector is like this, bicycle, if it is boat, if it is like the car, if it is like this is plane. Algorithm is learned. Any machine learning algorithm you can take. As we are going to be classify, you take any machine learning classification algorithm. You can take naive based, you can take k-nearest neighbor, you can take SVM, right? Whatever decision tree, whatever random forest, whatever algorithm you can take. Give your data. From the data, your algorithm will learn. So from that particular data given by you, learning happens. Once your algorithm is learned, algorithm will learn and learning is completed. Now I will give the test one. When learning algorithm will be completed, whenever the accuracy in the classification is 100%, the learning is completed within the stipulated number of inputs you have given. Within the specified amount of the training happened. I can't say the training is 100% completed and this training is enough for all the time. I can't say like that. Because whenever the new test sample came into experiment, and algorithm may not be seen so far, and you have to test the labeling given by the algorithm. Unfortunately, my algorithm is mislabeled. Actually it is car, but it is labeled as plane or labeled as some boat. It is mislabeled. So that is true negative, true false positive, false negative. There will be. What you are telling, actually it is a car, but you are labeled as a boat. That is the false positive. What you are telling. Okay, so based on the feature vector, your algorithm will learn, and once learning is done, it could able to give the mapping. As you are having training data and labels are available by skill, boat, car, plane. That is why it is a supervised learning. By giving this image, you are also giving the label. Based on the images given by and labels given by you, your algorithm learned. Okay, if feature vector is like this, it is a by skill. If the feature vector is like this is a board. That learning happens. Like if it is a circle, this is 0. If it is a vertical line, yes, this is number 1. And if you have a 2 curves in the letter 2, this is number 2. If you have 3 curves, this is number 3. How the kid learned? How the kid able to differentiate one alphabet with other, one digit with other. Like that, our algorithm will differentiate images. Okay, if this is the feature set, this is by skill. Other one, second one, bird. Third category, car. Fourth category, plane. That happens as you are giving inputs as well as label. If we don't have labels to the data, that is unsupervised. Learning happens without a teacher, without a mentor. Unsupervised learning is used when we don't have labeled data. It is main focus to learn more about the data by inferring patterns. Nobody there to say it is correct, it is wrong. Nobody is there to say you're going in a right direction or you're going in a wrong direction. Learning from themselves based on the patterns of the input given initially. That is called unsupervised learning. Here we can't see supervisor, you can't see the training data and decision like appeared in supervised learning. This particular phase is not there. I am not giving labels to the data. That is why it is unsupervised. Just take the input data is mixed. This unknown output is taken for consideration, taken for examination, and interpreting from this mixed data. Any unsupervised algorithm is trying to differentiate one data set or one element with other element, one object with other object. How it happens? Once it is identified, so based on important features, they are grouped into cluster 1, red cluster, green cluster, and blue cluster. No labeling, no labeling. It is just based on attributes, patterns, feature, nature. It is going to be group them into red cluster, green cluster, and blue cluster. But it is not telling what it is, like previous example. As I don't have labeled data, it is called unsupervised because the algorithms are left on their own to group the unsorted information by finding similarities. Similarities of pens are more, or closure, are similar compared to similarity between pen and the marker. Similarities among the markers are more. They are very similar, very closer compared with the other component, a pencil. So Based on similarities identified, it is going to be classified into, clustered into, based on the patterns identified. Patterns of pencil is different with patterns of marker, different with patterns on the pen. Unsupervised is most performed as part of exploratory data analysis. It is used in analyzing the data. Data analysis, important concept. It is having subset of data analytics, and data analysis is subset of data science. What is that? The science about data. The science include both art in nature and logic in implementation. It is most commonly used to find clusters of data and for dimensionality reduction. Unsupervised used to cluster the data and also used for dimensionality reduction when you have huge amount of the data which is not manageable. And when you have the third category, I can say here semi-supervised. In semi-supervised, if I have 20 elements, 10 elements are labeled, remaining 10 are not labeled, that is called semi-supervised. That is called semi-supervised. And the third different aspect of learning is reinforcement. Reinforcement. The reinforcement learning, it is the concept of learning based on the rewards given to the response. It is the continuously interacting with the environment, just like learning the car, learning the vehicle, the learning in the new environment, or robot navigation, or navigation of any interactive device that happens in the multiple rooms where environment is perceived. It is type of machine learning in which agent learns from an interactive environment in a trial and error way by continuously using feedback from its previous actions and experiences. When a question is asked, response is given, I will say 70% okay. Next, based on this particular reward given, next question is asked that associated with the previous question, 85% is correct. So that is the reward given to. Based on, so your progress is there in the learning because 70 becomes 85. Third time answer is given and reward given is 100%. So the learning successfully happens. So when the apple is, this particular fruit is given in the form of input, a mango, it's a mango. I tell you, it's a mango. Okay. So when this particular input is given and response is telling this is, response is mango. Actually, it is an apple, but the response is mango. So how we are correcting them is wrong. It's an apple. That is the feedback given to, assessment given to. Okay, when that correction is given or made by the learner noted, yes, if this is the input, this is an apple. That is noted. So whenever the second time the query is given, the new test or input is given, based on the learning happens previously, in the term of action and response or reward given to, the system learns happily and it is saying it's an apple. It's an apple. So that's the best example for learning is associated with the rewards. That's called reinforcement learning. So what is supervised? What is unsupervised? What is reinforcement? So in supervised, I will give the input data. I will give you the input data. So innovation is also given. I'm telling these are apples. These are all apples. Okay, so when I gave the images, when I gave the labels, my model will learn, and for the new one, for the new sample is given, it is predicted it is an apple in supervised learning. In unsupervised learning, what will happen? It is mixed. Mixed input data is given based on the features of the fruits, like color, like shape, like texture, weight. My unsupervised learning model is going to be clustered like this. Banana is one cluster. This is the second cluster. And third cluster also comes when the weights and the shape of the apple 1 group is bit different with apple 2 group. Based on the patterns of the data, my model is going to be cluster them, and it happens without any labeled one, without any supervised. That is why it is called unsupervised. In supervised learning model, this particular phase is available where it is not available in unsupervised. Right? So when I give these particular inputs and your algorithm is feeded and model is learned, and based on the learning capability of the model, whenever I gave the new sample, a test sample, based on the learning happened so far, it should be able to respond, and the response is precise. There are many machine learning classification algorithms. Classification algorithms are available. The prediction algorithms are also available. The linear regression, simple linear, multiple linear algorithms for prediction, and these algorithms for classification. Classification is labeling. Logistic regression, naive based, decision tree, k-nearest neighbor, random forest, support vector machine. These are the algorithms available in the machine learning used for classification. When your selected classification algorithm is not up to the mark, you can ensemble, you can integrate 2 or more weak machine learning algorithms to improve the performance of their classification. It's called ensemble learning. Booster, boosting or bagging. So the process of integrating 2 or more weak machine learning algorithms to prepare one hybrid algorithm whose performance is better than any available machine learning algorithms. That is called ensemble learning. Yes, it is also possible. What machine learning, how it is incepted? It is the definition given by Herbert Salmon, who got the Turing Award in '75 and also Nobel Prize winner in economics in the year '78. Based on his opinion, the learning is any process by which a system improves performance from experience. Best example, traveling from your staying place to your working place. In the first day, how much time is taken by your journey? What are the obstacles? What are the burdens you faced? Second day will be bit better than first day, because in first day you learned something, maybe 30%, maybe 40, maybe 90%, or maybe 10%. Second day journey will be smoother compared to first day. Third day will be better whenever you have the learning capability. If you don't have the learning capability, your classification, your prediction never be progressed. So to be progressed in the classification or in the prediction, you must have the learning. So on the 5th day of the same path, you will be reducing journey time. You will be reducing barriers. You will be reducing burdens involved. So the learning happens progressively from experience. Machine learning is concerned with computer programs that automatically improve their performance through experience. So what program you have given? SVM, Bayesian tree, naive based, logistic regression. What program you given? What algorithm you given? And what is the data set on which the algorithm is going to be worked out? The data set related to plant diseases, related to face recognition, related to the thumb impression, related to the speech recognition, data set related to the video analysis. What data you given? And what data set your algorithm learned? And how the model is prepared by you, and how it is ready to take the new sample to give the new label a true response which is more accurate. Though it is started in 50, why it is popular? Why not then? Reasons are flood of available data nowadays because of advent of the internet, increasing the computational power in terms of computing, in terms of interacting, in terms of storage space. Growing progress in available algorithms. Many algorithms are available, many are coming, many are hybriding, and many yet to come because of progressing in computation as well as in programming in the data set. The new algorithms can be developed and which are ready to take the new challenges, and also increasing support from the industries in the sense that there is a demand for the new algorithms, for new solutions, for new outcomes, for new technologies, for new concepts will be having the more weightage. Because of these reasons, ML, DL, AI, data science, IoT, all these concepts become popular and make easier and is very closer and convenient in the real world. Because of these, though the concepts incepted in 50s, due to lack of data, due to lack of algorithm, due to lack of computational power, due to lack of demand and cooperation, they are not flourished. They are not explored. They are not popular. They are not publicized. They are not came into limelight. There are many applications. The list is broader. It is not closed. The machine learning applications are many more. You name any application in which machine learning takes place. This particular domain is not confined to CSE and IT people, is not confined to ECE, EIEEE people. This is the concept used by any domain, any engineering or non-engineering domain. Even arts people can be used the algorithm. Science people can be used the algorithm, where they want to be develop the machine that is the capability of learning from experience. Any person can use, but what is the fuel? What is the important pillars of machine learning is data. Is data, second is algorithm. How you are using the algorithm, how you are customizing the available algorithm and make it a model, make it a learner, and use that learning model for the new samples where you are seeking for 100% preciseness. This is the list which is a very broader and having the large scope. The great person and the popular definition, and the writer is so much exposure in nature and having the knowledge in depth, named Tom Mitchell. According to him, the machine learning is improving with experience at some task. Improve over the task T. The task may be face recognition. Task may be plant disease identification, drug detection, drug prediction, Task may be speech recognition, task may be video analysis, task may be sentiment analysis, task may be anything, maybe prediction, maybe classification. Experienced on many tasks with respect to performance measure. In performance, the performance measure in face recognition of my model is 90%. The performance in plant disease identification is 95%. The performance of my model in video recognition is 97%. That performance, it is just like performance of the student, performance of the kid over the task given to. Test 1, test 2, test 3, test 4. By giving learning in various tasks, class is taken, content is given, stuff is given, and now I am conducting the test. And now I am assessing the performance of the, what is the performance after test 1, test 2, test 3, test 4. So when they have learned, and learning happens over number of tasks which are increasing, the performance of the model is also increases based on the experience gained so far. It is the study of computer algorithms that allow computer programs to automatically improve through experience. What are the sequence of steps involved in any learning process? The sequence of steps happens in early learning process. It starts with the real world where the data produces, from which the problem comes, the data comes. The data can be obtained using different devices, sensors, cameras, and other databases. Sensor, pressure sensor, the humidity sensor, the rainfall sensor, to sense all these attributes to predict the minimum and maximum temperature for tomorrow. I am preparing a chemical plant where different sensors are there to measure the depth of the volume of the boiler. All sensor is also there to sense the smell of it, the heat of it, the composition of it. There are different sensors that senses the environment producing the data. The pressure sensor, temperature sensor, humidity sensor, so many sensors, right? So cameras for image identification, image recognition, image analysis, video capturing, video analysis, video recognition, video conclusions. A simple database of Indian people who are having Aadhaar card, who are having passport, who are having the homes, who are having the particular loans. Databases given by different organizations. The data which is available and taken from the real world, which is not ready as it is to use, I need to pre-process. Pre-processing is required to prepare the data for usage. Without pre-processing also, the processing can take place, computation can take place, but efficiency differs, accuracy differs, because the data coming from the real world may be noisy, may be ambiguity, may be uncertain, may be incomplete. Then you have to use pre-processing steps to get the missing values. Imputation are used to get the missing values. Filters are required to remove the noise. Some processes are required to remove the ambiguity, to remove the uncertainty. So pre-processing steps is preparation of the data for usage that gives the more accurateness, more preciseness. Even normalization can be done as part of pre-processing to prepare the data for usage. And you have pre-processed the data, and your data is very huge. Sometimes it is unmanageable. your computational resources are limited or not higher in computational point of view, are not high end, they're having low end or medium end. So you have to reduce the dimensionality of the data to make it manageable, to make it comfortable, to make it the more controllable, so that we go for dimensionality reduction. You can use PCA, taxonomy, the feature extraction, feature reduction methods can be used to make it manageable, to convert unmanageable to manageable. When you have huge amount of data, I'm talking dimensionality reduction is required when you have the records in millions, then only it is required. Otherwise it is not required. Because of feature reduction or dimensionality reduction, there is a scope of losing important attributes. So once all these steps are done, you are preparing the model that should have the learning capability. That model can perform classification, can perform the prediction, regression, clustering, and some descriptions are possible. So once your model is learned, as it is exercised over the data obtained from the real world, after doing sensing it, after pre-processing it, after dimensional reduction, and fed to the model and learned my model over the data. Once learn is over, now we have to see the performance of the model by giving the new sample in the form of test sample. That model can be tested based on cross validation, means 90 training, 10 is testing. Last 10 is for testing, is one-fold cross validation. Two-fold cross validation is 80 to 90% segment is used for testing in the second case. In third case, 70 to 80 block is given for testing, three cross-fold validation. 60 to 70 block is given as a test. The fourth, this is called cross validation. The first case, last 10 for testing. Second one, 80 to 90 testing, 70 to 80. These validations are required to give the more training capability, more learning capability to the system. Instead of giving one-fold validation, my model having K cross-fold validation. K here it is 10. When I am having 10 blocks, 10 different blocks for testing. Once testing is done, see the performance of your model and measure the performance. Once you thought that performance is 100%, now the model is ready and released into the market to take the new inputs to give the outcome to the new samples, as it is prepared for best one for accurateness, as it is tested on different samples. For example, you are working on the application where you have to filter spam with non-spam. So what is the data for this? Email server. Email server gives us the mails received by users, include spam and non-spam. What are the features for this? If it is the spam and non-spam filtering or labeling, what will be the attributes? What will be the features? Number of recipients, number of people received the mail, size of the message, number of the attachments are there in the mail, number of means reply to the original mail in the subject line. How many attachments are there? Is there any image? Is there any video? Is there any audio? Is there any document? These are all features to filter spam with non-spam. If your application is face recognition, what are the features of face recognition? Shape of the face, length of the jaw, the distance between two eyes, length of the nose, distance between nose and the lips, distance between lips when you are closing, when you are opening. If you have mustaches, length of the messages, depth of it. These are all attributes. These are all features. These are all features. You must learn to conduct face recognition. If you want to see the image recognition of fruit, image size, image shape, weight, texture, these are the features. These are the features to classify the image. So based on features, the model is algorithm will learn, maybe classification or prediction. Algorithm will learn. The algorithm you can customize. Initially you take SVM, you can take random forest, KNN. Based on the data, based on the performance you obtained from the model, you can customize it. So that is why by making the changes to the existing, you can prepare your model. That is the machine learning model. That model is ready to take the samples from the new environment as test samples and to give the response to that. Or you can use existing methods as it is. And there is no guarantee that all existing methods will give the 100% results to your data set, because those models are developed based on the data sets of them, not of data set of yours. That is why the existing models may not give the better results, 100% results. You need to customize it. That is your own model. By making customization, you will prepare your own model. If you want to filter spam and unspam, what data set? Number of new recipients. What is the length of the mail in terms of kilobytes? What is the source and destination of the mail? What is the customer type? Based on the mails uses by the Gmail, Yahoo Mail and other mails, they will customize you either gold, silver, bronze, and what type of mail it is. That is the data set. These are numeric features, as in numbers 0, 1, 2, 3, 4. This is nominal. Nominal means order, January to December, Monday to Sunday. They are nominal. Ordinal. Ordinal means the group of category of C1, C2, C3. CSE student, IT student, EC student, ordinal. The gold customer, bronze customer, silver customer, ordinal. Once you have these independent variables, this is dependent variable. If these are, and this is determined, you are going to be predict. You are going to be classify based on these attributes. Spam, not spam. Data set which is trained. Based on the trained data set, the algorithm is learned something, and that is going to be classified spam, not spam. Now once your algorithm is ready, what you have to test with new mails received. So that model should be able to say, if it is spam, go to dustbin. If it is not spam, keep in my inbox. So out of 100 mails received, 90 is not spam, 10 is spam. My model says out of 90 non-spam, my model says 80 as spam, 10 non-spam as spam. So 80 by 90 is correct one, and 10 by 90 is wrong one. Though last 10 are non-spam, but model is telling it is a spam mail. That is called, it is telling positive. Though it is not spam, it is telling spam. Here spam means positive. So that is wrong. So what is false positive? That is called false positive. Though the mail is not spam, my algorithm says it is spam. Here spam is positive. So that is a false positive. For 80, it is telling it is actually they are non-spam. My model also tells non-spam. This is called true positive. So what? And it is still so the 10, actual 10, it is a spam. Spam is positive. Yes, it is considered those 10 as positive. Those 10 as spam. Actually spam, and my model tells also spam. So that is true positive. That is true positive. So that is done based on accuracy matrix, confusion matrix. That confusion matrix will have true positive, true negative, false positive, false negatives. There are number of learning algorithms available so far, and there is no guarantee that algorithm from this particular pool will helps you to your data set, because the data set what you are going to be used is newly taken, that is not experimented so far. So no algorithm gives you, no existing algorithm gives you 100% prediction or 100% classification is accurate on your data set. That is your context, because they are not tested on your data. That's also done with the classifier. So email length is taken, new response is taken. Why it is called linear classifier? The simple y equal to mx plus c, y equal to mx plus c. So x is input, m is slope, and c is intercept. Whether the line is touching here or here or here, where it should be, that is intercept. As single line is enough to differentiate spam with non-spam, it is linear classifier. Single is enough to filter spam with non-spam. But where should I draw the line? Either here or here or here. So this is called B. Y equal to mx plus b, if you are considering. Y equal to mx plus c, if you are talking about c as the intercept. X is new mail. The length of the mail, attachments are there, that is the x. M is slope and b is the intercept. So linear classifier is the concept where single straight line separates two classes, class 1 with class 2. But there are different ways of classifying them. Which line is correct? This line is correct till now. But whenever 10 more new mails came, this line may not supports, may not gives the true answer for all. That will be defined by the. So what is the line should be that will be applicable for great many contexts? That is called a margin. That margin of linear classifier as a width that the boundary could be increased, that hitting the data point. So this margin should be very broader. So to give the clear separation from class 1 to class 2, that is named as the maximum margin of linear classifier. With the margin, the simplest kind of SVM is given, the support vector machine, that gives you the it will try. This is the kernel, that is kernel is trying to give the maximum separation, that is going to give the clear separation, clear distinction between two classes, class 1 and class 2. If you are not having that particular precise classification capability, what will happen is the new mail is actually it is spam, but falls in non-spam. That's possible with the improper preparation of the model to classify spam with non-spam. Actually, this is spam falls into non-spam, and this is non-spam but falls into this one. There are two errors. Right? So this is called, this is actually a not spam, but you are telling spam. This is called false positive. What you are telling positive is false. This is a false negative. This is called false negative. You are telling, right? So in this particular context, how the model is going to be learned, how your model isolates spam with non-spam. But all the time, a single straight line may not sufficient to classify two classes confidently. So situation is like this. When situation is like this, no single line is drawn like this to isolate. So that is called non-linear. So that non-linear, yes, that non-linear line will gives you the process of considering every sample and classifying them. Too much classification, too much training yields to overfitting. Too much training is done to your model. Too much samples are given to your model while training happens. That is overfitting. Overfitting is very, very narrow down, sensitive to the context, but model should be a broader, it should be a generic, it should not be a specific. So don't go to too much training. The too much training goes to or yields to overfitting. I told you the confusion matrix now. Actually 8 are blue, 5 are red. But model classified 7 as blue and 1 is red. This is true positive. This is true positive and this is true negative. So actually this is also blue, but it is considered as red. In point of 5 red, this is properly done. It is properly done. There are 5 red dots. 5 are properly classified as red dots. So this is true positive. This is true positive. This is also true negative. You are saying 0 blue dots. Yes, this is true. This is true negative. In point of red, I am talking. In point of blue, actually 7 by 8 are true positive. 7 by 8. 7 blue, actually 7 are blue, classified also 7. So 7 by 8 is true positive. This is true negative. You are telling 1 is not blue, 1 is red, 1 is not blue. 1 is not blue is not blue. You are telling. So this you are telling as negative. Negative means not blue. That is false. That is false. Actually, it is also blue. So that is the confusion matrix. So based on performance with respect to blue, what is the accuracy? 7 by 8. 7 by 8 is the accuracy. With respect to red, your model accuracy is 5 by 5, 100%. 100%. Okay. Error is with respect to blue, error is 1 by 8. That is error. 7 by 8 is positive and 1 by 8 is negative. So error is the difference between modulus difference between actual and classified. Error should be 0. Then your model is ready to take the new problems. How it will be done? Based on back propagation. That the issue we'll discuss in the coming sessions. So this is non-linearly separable case. No single line separates it. Not correct. So this is like this. So, but how? If it is the linear classifier, I can simply say y equal to mx plus c. I can say. But it is non-linear. How you will draw? This is complex pattern. This is the shape is very complex to draw. As it is non-linear. Either that is correct or this is correct. This is correct because it separates red with blue samples. It is not able to separate like that. Which one is greater? But too much training yields to overfitting. So there are overtraining is called overfitting. Lesser training is called underfitting. Lesser training means your model prepared on few samples only, trained on few samples, not exhaustive samples. That is called lazy. There will be algorithms which are lazy to learn. If the algorithm is lazy to learn, that goes to underfitting. Underfitting means that will not give the better performance while testing them. Okay, it is accuracy will be given, but that accuracy is not 100% because the learning is not completely done. Legendary, KNN is called instance-based learning. KNN is instance-based learning. So whenever admission process is over and the first day classwork is open and students are sat in the classroom and student enter into, the student will not know the exact place of to be set. After 1 day, 2 day, the student able to identify the position based on the matching or similarity of his or her habits with co-students. So maybe close friends are 2 or close friends are 3. How he is determined? I should have 2 friends max. I should have only 3. I should have 5 friends. I should have 10 friends. Based on that number, either 1 friend, 2 friend, 3, like that, the student seating position will be determined. The key K nearest neighbor. So the position of the new sample determined based on the K value. Determining the K value is based on experimentation. It is just like determining the K value for key means algorithm. But KNN is classification supervised. K means is unsupervised one. The determination of K, I will say, is based on experimentation only. There is no standard procedure to know the K value because the data set what you are going to be consider for your experiment is not old one. It is not fixed. It is new one. So no fixed value, fixed procedure for K, either in K means or KNN. It is based on experimentation only. Not only this, all machine learning, deep learning, AI algorithms are improved based on experiment only. There is no standard fixed algorithm for a fixed domain, for a specific context, because there are many differences between your case and the case what is already handled. Maybe data, maybe computation, maybe labels given, maybe outcome you are expecting, maybe accuracy out expecting, might be anything. There are different conditions where that differentiates. Too much training is called overfitting, lesser training is called underfitting. Overfitting means your model is done in training, but whenever testing comes, it won't do well. It won't do well, overfitting. Underfitting means lesser training is given, lesser training, right? So as lesser training is given, it may not possible with the capability of giving the outcome. That underfitting, when model is too simple, both training and test errors are large because it is trained less, it's trained on few samples, then both training and testing are error. That is called underfitting. What should we do? So why should we go for deep learning? Why should we go for deep learning? Though we have plenty of machine learning algorithms which are already implemented, tested, and better fruits are coming from them. But why should I learn? Already I learned a lot of things. Why should I learn the new things again? Why should I go for some risk position from the comfort zone? The comfort, the limitation is just an imagination. Limitation is just an imagination. The comfort is the limit, is the circle drawn by you. This is just imagination. You are not trying to learn the new things. You are not trying to learn the new concepts. You are not learning. You are not ready to take the new challenges. When you are ready, then we look for alternatives. You are ready. We are looking to give the best solutions for new challenging issues. Though machine learning algorithms are plenty, implemented, tested, available, easy to get, easy to learn, easy to use, there are some drawbacks also, and there are pitfalls also, there are some limitations also. That is the reason we have to go for the deep learning. As advantages are well known and no need to touch, I will focus on disadvantages. By focusing on them, we need to switch into the deep learning. That is, data acquisition is not easy. It is not automated. Sometimes the data acquisition is not automated. It is not complete. Sometimes it is not precise. It is not certain. It is not accurate. Yet the best fuel. I'm requesting the participants to mute yourself. Requesting the participant to mute. Please mute your mics. Otherwise, we will mute from our side. Yeah. The time and resources. The time includes selection of features. The basic difference between machine learning and deep learning is, in machine learning, feature selection should be done by the system or selected by the person, a programmer or the owner who are working on that. Sometimes the person not have the capability to select the better features. So if that is the case, what will happen is we can't expect the better regression or better classification if you are failed to select the suitable features, because all features are not uniform, not having the equal importance. By mistake, you have selected the features whose weightage is less compared to others. But unfortunately, you selected the features whose weightage is less compared to the features whose weightage is more. Where you will arrive? You will be arrived at the lower accurate because of time sense, because of experience, because of resources not having. Interpretation of results. Interpretation of results is also one of the reasons where the machine learning, because of manual intervention to identify the feature selection, manual intervention to obtain the data, manual intervention to prepare the model. Because of these senses, sometimes interpretation may go wrong. When interpretation goes wrong, in terms of data, in terms of learning, in terms of outcome assigned, the model is not perfectly prepared, so that it will not give the 100% accurate results either in prediction or in classification. And it is also error prone in terms of susceptibility because of the properties of incompleteness, uncertainty, ambiguity, and missing values, and overlapping or misinterpretation. The model is error prone. That is why, and few more reasons are also there to come into deep learning. The deep learning, the machine learning is just the preparation of the machine to learn from experience. It is like a computer algorithm, computer program. The machine learning from experience. But machine learning capabilities are not enough in all the context because they are not able to give the results as human expert gives. When I'm expecting results as equivalent to human expert, the deep learning is required because human beings have the capability of perceiving, flexibility, identifying the patterns, ability to interpret the complex environment, and giving the conclusions within the lesser time. These are the capabilities of human being. So I don't have these capabilities from machine learning. Though machine learning is learning from experience, it is not having the cognitive in nature. It is not flexible. It is not perceived in nature. It is not dynamic in reasoning. It is not active in ambiguity context. It is not suitable in uncertain because it is a machine. It is an algorithm. It is not a human expert. I want the system should act as a human expert. So how should I do for that deep learning? Because deep learning simulates the new human brain. It simulates the neuron. Deep learning works on artificial neural network. It is going to be used the plenty of neurons with multiple layers, with multiple stages. It is almost I am creating a human brain. I'm trying to create the brain in terms of a computer programming. That's why it is called deep learning. Deep conceiveness, deep perceiveness, deep reasoning, deep understanding. The human become expert. The machine learning doesn't have that capability. So what I should have that capability with the programming, which are to be gives the solutions as equivalent to human expert. Deep learning algorithms are roughly inspired by information processing patterns. The great advantage of human being is just walking on the road, but just by seeing the objects, immediately the labeling is given to the object. Immediately react to the dynamic world. Suddenly a vehicle came across. Some object fall on to. The immediate response comes from the human because human have the capability of understanding, processing the patterns. The same patterns a program should have. Those patterns, those capabilities not available in the conventional or advanced ML as it is. Just like we use our brains to identify the patterns, classify various type of information. This is X, this is Y, this is a laptop, this is a desktop, this is a mouse, this is the bottle, the person is XYZ, the person is ABC. How they are able to identify patterns and classify various type of information. The deep learning algorithms can be taught to accomplish the same task for machines. The response should be immediate. The response processing should be deeper. The results should be accurate. That is my goal. That's why I should go for deep learning, because the deep learning is simulating, is programmed as human brain. The brain usually tries to decipher the information it receives. It achieves this through labeling and assigning the items into various categories. Just by looking into the dog, yes, this is the dog. Looking into some person, yes, this person is ABC, he is my friend. This is person XYZ, he or she is my colleague. How it is happened? Because my neurons are programmed, learned. As my brain neurons are learned, and I'm able to immediately receive and labeling it. The same capability I want to give it to the program. Whenever we receive the new information, the brain tries to compare it to a new item before making sense of it. If I don't have any experience with that item, with that person, this is the first time, I will give the new index to that particular person. I will give the slot in my brain with the new name, with the new label, which is the same concept developing algorithms employ. For example, artificial neural networks are a type of algorithms that aim to imitate the way of our brains make decisions. As it is simulating the brain, they are called deep learning. The fuel for deep learning is, the basic building block for deep learning is ANN. The fuel for machine learning is data. While DL can automatically discover the features to be used for classification, ML requires these features to be provided manually. Yes, we have to give the features. If you are fruit recognition, shape of the fruit, type of the fruit, color of the fruit, weight of the fruit, texture, which you have to give mention, which you have to mention manually. Face recognition, you have to specify shape of the face, mustaches are there or not, length of the nose, length of the jaw, distance between nose and lips, these to be given manually. But all features are not same. When your learning algorithm gives 100% result, when features are perfectly identified and those features are taken for programming with the accurate weighing parameters. Feature 1, feature 2, feature 3, feature 5. But weights are not same for all. W1, W2, W3, W4, not same. How you are able to determine the weights for x1, x2, x3, x4 for better only one combination x1 w1, x2 w2, x3 w3, x2 w4. The face recognition gives 100% accurate for only one combination. For other combinations it fails because the weighing parameters are not properly determined. Weighing parameters is the objective, is the functionality of machine learning algorithm. Anyhow, input is easy to get, but considering input and giving weight to them as part of regression or classification, machine algorithm efforts, the talent is fully determined by estimating weighing parameters like W1, W2, W3, W4 for inputs X1, X2, X3, X4. There only the weight comes. In context ML, DL needs high-end machines. ML can be done with CPU, but DL needs GPU, graphical processing units. Almost training done on GPUs, and the feature selection is done automatically in DL rather than human intervention in ML, and the computation speed and time required for training is also differs. Simple illustration I want to give, and it should be there into your mind forever, is the machine learning how two different steps for feature extraction and classification. These two are done as one unit in deep learning, and this is done by program only. Your human intervention is not required. It's done by your program. Depends on what is the image you taken, how it is represented in pixels, and how those pixels are integrated, combined to know the pattern, to know whether it is a car or not. The program will take care everything about your input and your objective. You no need to worry about. But in machine learning, you have to select the features. If you fail to select the proper features, then your outcome is not acceptable. As I told you, if you take these, and these are the features. The feature is like shape of it, color of it, texture of it, and boundaries of it. So many things take into consideration. Based on them only, the machine learning occurs. But in deep learning, just by giving these images, it learns. It learns. You no need to worry about how to select, how to extract the features. Automate feature extraction using DL is the best effort, advantage, characteristic of deep learning, where the deep learning results are more accurate than machine learning, and which are most welcome in great many contexts. Sometimes you will be flooded with so many inputs, maybe 1 lakh records you have, maybe 10 lakh records, 10 lakh faces you have, but still your machine can learn from them, and the machine is ready to give the label to the new face also successfully. At that, you need to have PCA, where the principal component analysis will reduce the dimensions, and also able to identify important features to be preserved, to identify the best features from the final conclusion. An image practice needs to extract the feature manually in the image like eyes, nose, lips in the machine learning. But whereas in deep learning, it will automatically done. It will select the features and will take the better weights for the better combinations of pixels for giving the better labeling. Example, I will show you here it is. So this is Audi 7 version car. I will give this image to the deep learning model. My deep learning model should give the label Audi A7 to this particular car image. This particular car image. If it is the machine learning, you need to specify car shape, car color, the edge boundaries, weight of it, height of it, the sometimes size I can say, and so many features which are to be identified manually and give to your program. And all those features doesn't have the equal weights W1 W2 like WN, where you have to identify, and the model has to identify the proper weightage for them. But if you have the deep model, just by giving this image, every pixel is treated as a feature map vector. Every pixel, if it is 100 by 100, there will be 10,000 feature vector. 10,000 feature vector space. Your vector space is 100 by 100 if it is blackened. If it is color, 100 by 100 into 3, 30,000 features are there in the image, and your model is going to be combine every pixel or feature with the rest of the feature for the better combination to be the part of the original image. It selects the filter. That filter decides the pattern selected by the deep learning and to determine whether it is the part of original image or not. The filter is selected when matching is there between the pattern identify the model and the part of the original image. Based on this matching between pattern identified by the deep learning and the sub part of your total image, this filter is selected. Filter 1, 2 by 2, 3 by 3 filters are determined. About filter, about convolution, about spooling, we will discuss in the coming sessions. There are many contexts where we are seeking for the deep learning applications. These are the real world applications, requirements. Like like human vision, I want to have a computer vision. So what is that? My computer should be able to perceive the video, perceive the audio, perceive the image, and should respond immediately. Should be able to identify the video, should be able to identify the audio. So what capabilities human eye have should same capabilities I'm expecting from the computer eye. Through CAM, perceive, environment perceiving, testing, and interpreting. Speech recognition, identifying the audio, identifying the speaker based on the speech produced by. Language translation, so as to target. Planning and decision making, it is required in professional life, in personal life. If you failed in anything, you failed. If you want to be succeed in your career, both should be properly planned. Decision making should properly done in both personal and professional. So there are many contexts, many requirements in the real world. But who will give you the solutions? Until you don't look for, until you won't see for, who will? Nobody. We have these abilities. We have the task to be done, like speech recognition, video analysis, audio analysis, language translation, decision making, prediction or classification. These are the tasks to be done. But how they will be done? Until methods are there, techniques are there, algorithms are there, we can't. But expert system, if long neck is there and it will return giraffe. When it is bushy tail, then it return the horse. When there are spots on the body of the animal, it is the giraffe. The rule-based system, expert system available based on rule-based system. In machine learning, prediction and classification is done based on the data taken, features identified, and algorithm capabilities. My machine algorithm is able to predict or classify based on the data given and algorithm selected. Still not satisfied. I need to have autoencoders or language translation, decision making, video analysis, sentiment analysis, and all these tend to be done in the form of deep learning. So what are the differences? The differences between machine learning and deep learning happens with respect to data dependencies, excellent performance on a small or medium. If the data is more, like lakhs, millions in terms of text data, numerical data, or in terms of images or videos, deep learning is the best option. Machine learning fails when you have huge amount of the data. Hardware dependencies. Machine learning works on only low-end systems. When you have GPU computations, when you need the computations storage for the high-end computations, then we go for deep learning only. Require powerful machine, preferably with GPU. The DL performs significant amount of matrix multiplication instead of the array manipulation. Instead of bit-to-bit computation, it is going to be performed on matrix computations. Feature engineering. You need to understand the features that represent the data in the machine learning context by manual. But whereas in deep learning, you no need to understand the best feature that represents the data. You need to perform exercise here. The model will do the exercise to identify the better features and to come up with the best output. Whereas in machine learning, it is manual. You need to do the brainstorming process. We need to have experimentation. We need to have exercise. You need to spend some time to identify what features will give the best outcome. Execution time from few minutes to hours in machine learning when the data is manageable level, whereas in deep learning, it takes weeks of time if the records in millions. Images are millions. Neural networks needs to compute a significant number of weights. Nearly, for image recognition, I told you, whether it is a bike, car, boat, something, for image it takes nearly 130. It takes 100 MB of data per image, 100 MB, and 138 million parameters to be processed by the deep learning for identifying the image, whether it is a bicycle, boat, cycle, right? We have the plane option. So there, actual image size is 1.5 MB, but in deep learning, to process the image in deeper, it needs 97 to 100 MB of the data. Storage space is required. And it needs to process 138 million parameters, million hyperparameters, weighing parameters, 138 million, 138 into 10 lakh hyperparameters to be processed. So no machine learning algorithm is suitable for that until deep learning model is available. Interoperability. Some algorithms are easy to interpret, logistic regression, decision making. Some are almost impossible because in SVM, how to determine the kernel, especially in nonlinear, it is not easy to determine the kernel in nonlinear. It is not easy to integrate the weak machine learning algorithms to prepare the strong machine learning algorithm. Difficulty in machine learning, but the intensity of that interpretability is difficult to impossible when your data is complex and it is having the patterns of complex. When to use ML and when to use DL. When your training data set is limited, small, go for machine learning. And you have the option to choose the parameters and enough capable, go to the machine learning. Number of algorithms are many are there. Number of algorithms are there and you need to integrate as a booster or ensemble to improve the quality or capability of the algorithm. You can mix SVM with naive based. You can mix the random forest with logistic regression in ensembling process. You can mix KNN with the logistic regression or some other. Yes, you are able to integrate them, then you go for. Training time is shorter, so data set is shorter, features are shorter, and features need to select manually and capable. Number of algorithms available are more, and training time is lesser, go for machine learning. Otherwise, vice versa, training data is larger, features need not to select, you need not to interfere manually. Number of algorithms are very fewer. Don't you have the option of ensembling them? And training time is longer available, then go for deep learning. Go for deep learning. Machine learning is a simple concept doing with a little bit effort, but deep learning is the greater effort obtained from proper usage of the human brain. There are so many applications of deep learning. The great complex applications which are contemporarily required in the pandemic situation: drug properties prediction, novel drug design, and target interaction of the new applications in the medical field. Now to process the medicine available with the genome or input patterns, transcriptome, which are called combinations of input variables, proteome, used to analyze the samples and the combinations, and finally assessing the drugs which are prepared from the process. DL architectures are broadly 3 classes. Maybe these will be go for in detail explanation in the coming sessions. Just I want to glance you CNN, convolution neural networks, recurrent neural networks, and recursive neural networks. Convolution, the word taken from the mathematical field, is going to be convolute. Convolute the features on the canvas, and the mapping and the pooling all these inputs to prepare a model for better learning. In deep learning, the CNN is the basic DL accept, where you have images, videos, and it will take the input in terms of number of images. If it is the face recognition, image height, image width, 100 by 100 by 100, for example. Input channel, as it is color 1, 3 channels. So I have 10,000 images, each of 100 by 100 height and width, 3 channels RGB into 100. That is my data set size. 10,000 into 100 into 100 into 3. This is the data set size. No machine algorithm is compatible to deal with or capable to deal with. But all these are mapped into feature map height. Feature map means image height. Feature map width means image width. Channels means 3. So all these features are dumped onto the canvas. It's convoluted, then pooled, and mapping is done to come up with the better solution. Recurrent network, CN is normally used for image recognition, image analysis, image classification. Recurrent networks are used for connections between nodes from a directed. For example, natural language processing, speech recognition, video recognition, continuously coming. There it is recurrent network. So image recognition by CNN, speech recognition, video recognition by recurrent. The name implied recurrent. Handwritten recognition, speech recognition are the specific applications of recurrent networks. So this is the list for recurrent networks. Machine translation, robot control, time series prediction. Time series means tomorrow's temperature, tomorrow's COVID cases, tomorrow's gold's value per gram, stock market, rainfall prediction, crop prediction, student performance prediction. All these time series continuously happening, and continuously coming. It is recurrent neural networks. In prediction, continuous data is required. Third category is recursive. Recursive and recurrent are a little bit. Recursive use the experience obtained in the past. Recursive function, factorial of a number, factorial of n equal n factorial equal to n into n minus 1 factorial. N minus 1 factorial equal to n minus 1 into n minus 2 factorial. So it uses the experience gained from the past. It is called recursive neural networks. Applications are listed like this. Will be discussed in detail in the coming sessions. So traditional ML will take the model independently. We take the model in isolated manner. But the performance of the model taking isolated one and independent one may not give the better performance. What we need is, I need the model which is experimented on huge amount of the data and which is learned a lot, and that will be help me in my context. It is called transfer learning. Transfer learning is the model selection which is learned a lot all on the huge amount of the data set, and which I want to take it as it is and do the little bit modification called customization, and which I want to use in my application. As you are learning the transfer, as you are taking the capabilities which is already obtained from the previous context to your context, you are transferring the learning from all learned to new context. It is called transfer learning. Resonant, AlexNet, DenseNet, LeanNet, VGG 16, 19 comes under transfer learning. They are the network models produced by the Google, Amazon, developed on huge amount of the data set, includes images, videos, audios. They learned a lot from experimentation. So you can use them and you will improve performance in your specific context. CNN networks, models, VGG, Alex, Dense, all are ready for usage. Already they learned. So don't build them from the inception. Use them. Already done and got the better results in terms of 99. I used the transfer learning of VGG 16, 19, AlexNet, DenseNet for plant disease identification to be done as I am working on the projects supported by the JNTUH under collaborative research scheme. I did for plant disease identification. My model should be able to identify whether it is bacterial, fungal, or viral. It is tested on 18 categories of the crops. Each crop will have bacterial, fungal, viral, and each one I have nearly 3,000 to 4,000 images. 18 into 4,000 images into 150 by 150 images of 3 channels worked on. This is only possible because of deep learning is welcome. As I have transfer learning capability, is going to be gives you the best for your requirement when you have huge amount of the data in your context. This is the list for deep learning and transfer learning: Alex, Cafe, Inception, Resonate, and VGG series. Select the source stock, develop the source model, reuse the model, and tune the model, because all available models are not 100% accurate to your context, because your context is different, your objective is different. So you change bit and do the better for 100% accuracy. This is about differentiating machine learning with deep learning. Now the class is open to take the queries from you, and I'm ready to take the responses to your queries based on this query related to the context. If you have any queries, unmute yourself and ask. Thank you for your patience listening.
Thank you, sir. Thank you, Srinivas sir, for your sharing great knowledge with us. Participants, if you have any doubts or queries, you can post it in the chat window, or please unmute yourself and you can ask. We'll take queries for another 2 or 3 minutes, then we'll break.
Good afternoon, sir.
Yes, sir, continue.
Sir, for EEG signal data, which model is suitable, sir? Or which deep learning model is suitable to analysis the EEG signal?
Okay. ECG, right, sir?
EEG, sir. Electroencephalogram.
Okay. Is it a continuous signal, sir, or you are taking as
Yes.
isolated?
It's a continuous signal, sir. Time series signal.
So recurrent. In deep learning, I told you CNN is for images. Okay.
Okay, sir.
Take recurrent neural networks. Recurrent. That helps you. Yeah. As it is continuous and it is input is in terms of signal, RNN supports you. RNN is the best one. and you will see the real performance of the any deep learning model until you have the sufficient data size, thousands, lakhs, millions. As much as data is more, your model will learn a lot and you will see the real performance of that. If you don't have the sufficient amount of, if you're concise to the data set, limited one, you won't see the real performance of the deep learning.
Thank you, sir.
You will get the data set from GitHub, sir, for easy, for many domains. We have the
PGONet, sir. PGONet.
Yeah, I'm telling the source where data sets are available.
Okay, good.
Yeah.
Any more queries or any clarifications you need? Just now we have forwarded the attendance cum feedback link in the chat window, Meet as well as in YouTube also. I request all the participants to fill out the form only for forenoon session. That form is only for forenoon session. Even afternoon also we'll have attendance. We'll send that link at after 3:30. So any questions from the participants? So we'll take a break for lunch. Thank you so much, Dr. D. Srinivas Rao sir, for sharing greatest knowledge with us. Thank you once again. So we'll take a lunch break, and next session will start at 2 o'clock. Next talk is on Insights of Neural Networks, a practical session by Mr. M. Ramesh, TCS Hyderabad. Swati ma'am and Suresh, in the feedback form, it is mandatory to fill your participant ID. So that is a required field. Maybe that is the reason why it is showing error. The rest of the people have already filled the form. Please find out your participant ID in the list what we have sent you yesterday, and in WhatsApp group also we have given you participant list. So in that PDF document you can find out your ID, participant ID. Still, if you have any doubt, you can ping me in my personal window.
Hi, Hal. Ramesh has been joined.
Yes, sir. Thank you, sir.
Yeah. Hi, Revati.
Yes, sir. We welcome you to this STTP, sir, Machine Learning and Deep Learning Techniques for AI Problems Using Python. We welcome you, sir. So we'll start the session in a few minutes, sir. welcome back. Now, the session is on Insights of Neural Networks, a practical session. And this talk will be given by Mr. M. Ramesh, a software developer, TCS from Hyderabad. So before hand over the session to Mr. M. Ramesh, let me introduce him. Mr. M. Ramesh, who is working as a software developer and who is well-rounded professional and quality analyst, and he's having 9 years of experience in Tata Consultancy Services from Hyderabad. And Mr. Ramesh did his BTech in JNTU Kakinada, MTech in JNTU Hyderabad, and currently he's doing his PhD in NIT Goa. And his PhD topic titled Brain-Computer Interface Using Fuzzy Techniques. And Mr. M. Ramesh is expertised in Salesforce, ETL testing, web services, and cloud server. On this note, I welcome you, sir, Mr. M. Ramesh, sir, to take over the session.
Yeah, thanks, Revati. Thanks for introducing. I will share my screen.
Sure.
Yeah. Are you able to see my screen?
Yes, sir.
Yeah. Okay. Today I will discuss about artificial neural networks. Today my topics is introduction of ANN, perceptron, and back propagation algorithm, and probabilistic neural networks, convolution neural networks. So after that I will show some practical also. So first I will discuss about artificial neural network. So artificial neural networks means consist of pool of simple processing units which communicate by the sending signal each other over large number of weighted connections. See here, neurons means it is called as building blocks, that is neurons, that we also refer them technical system that we call units and nodes. So basically neurons, what it will do is, neurons means it is receive the input from many other neurons. So then after that it is changing its internal state based on the current input, is sending the one input signal to many another neurons. This have to do the neurons. So then it is a technical point of view and biological point of view. Technical point of view, we define the neurons. Some problems such it is neural networks, we have to find out the character recognitions, as well as we have to find out the predict of the future, that we call a technical point of view. Then other biological viewpoint of view, ANN can be used to replicate and simulate components of the human brain. So then how do ANN works? See, this ANN neural networks, artificial neural networks, is neither hardware implementation or computer programs such as a stuff to simulate the information processing capability of biological exemplar. So ANN technique for solving the problem constructing software works like our brains. See, the brain as a massively parallel information processing system, our brain huge network processing helmet. So typically brain the contents of network 10 billion neurons. So this is the brain, how it is works. See, the brain having some parts, dendrites, cell body, axon, synaptic. So dendrites means it is a input, cell body means processor, synaptic means links, axon means output. So neuron is connected to other neurons through about 10,000 synapses. A neuron receive the input from other neurons. Inputs are combined. See, once it is input is exceed critical level, the neuron discharge to spike an electrical pulse to travel from body down the axon to the next neurons. Axon ending the almost touch the dendrites or cell body of the next neuron. The transmission of the electrical signal from one neuron to the next affected the neurotransmitter. Neurotransmitters are a chemical which are the released from first neuron and which bind to the second neuron. See, this link is called synapse. The synapse means the strength of the signal reaches the next neuron depends on the factors, the amount of the neurotransmitters available. See, this is a biological neurons. Here, artificial neural network. The here dendrites, axon neurons. So neurons will receiving the input signal. It is passed to the another neurons. Dendrites is a connecting the neurons. Axon is a processing the data. So same thing here. Artificial neural networks X1, X2, X3 is a input signals. The weights are we have to user define the weights, then we have to send the input to layers. So hidden layer, here we have some layers, input layer and hidden layer and output layer, that we have discuss later. So here this is a single neuron. A single neuron means it is a input x1, x2, x3, x4, x5. These are inputs. W1, W2, W3, W4, W5. These are weighted the inputs. These are W1, W2, W3, W4. These are user defined the weights. See, these are three layers: input layer, hidden layer, output layer. See, this is input layer. Then after we sending the inputs, then we define the weights W1, W2, W3. After that we have to find out the summation. After that we apply in the activation function. After we have to find out the error. That we after find out the error, then we have to update the weights. Then we will go for feed forward networks, that we will tell you later. So artificial ENN compute any computable function, appropriate selection networks, topology and weights. See, this is continuous process, trial, evaluate and adjust. The process input they produce the output. See, what we given the input, processing the input, then we train the data, then after we will get the output. Evaluate means evaluating this output by comparing the actual output, the expected output. These exclusive are these I will tell you exclusive what is the difference between the and exclusive. See, what is these neural networks design issues. So here initial weights, some random values we have to give -1 to 1. Transfer function, so how the input function and weights are combined to the produce output. Error estimation, weights adjustment and number of neurons and data representation, size of training set. The transfer the functions. See here after we sending the data, we have to produce the weights. After that we have to find out the threshold limit. Based on threshold limit we have to classify the data. So here linear, threshold and non-linear. See, linear means output is a proportional to the total weighted input, that is called linear. Threshold means output is a set one of the two values. So it depend on the whether total weighted input is greater than or less than. So I will tell you later threshold limit. So non-linear, the output varies continuously but not linear as the input changes. Error estimation. See, error means for example our output value is 5. I will after I'm producing the neural network, I will get the 4 value. Say actual value is 5, 4 value is 4. Then this is we find out the actual value minus present value, that we will get the error value. activation function, the step function, sign function, sigma functions. These are simple networks and or not functions. See the perceptron. Perceptron means here inputs, weights, and activation functions. See here inputs means x1, x2, x3, so on, xn. Weights wn, w2, and so on, wn. So here we have to find out summation a equal to summation of I equal to 1 up to n wi into xi. So here xi equal to 0 to 1. See here theta, for example, theta means threshold value. See a is equal to greater than or equal to the threshold limit, then that is called as considered as 1. If it is a is equal less than or equal to theta, that is considered as equal to 0. See if you based on the theta value, we classify the data. So here 1 is represent is one side and 0 is represent is another side. So based on this equation, w1 x1 plus w2 x2 equal to theta. So linear separability. So here and or, see or we can see and operation is equal to 0 0 equal to 0 0 1 equal to 0 1 0 equal to 0 1 1 equal to 1. So here target value equal to 0 0 0 1. See actual value equal to 0 1 1 2. So based on the theta value, we have to separate separability using AND operation. We can easily separate to 0 and 1. See here 0 or one side or 1 is another side. See here we are using the logical operation, logical exclusive or logical XOR operation. Then we unable to divide it the classification. See here 1 is one side, 1 is one side, 2 is one side, 0 is one side, and 0 is one side. So this is a drawback of linear separability using the logical OR operation. See, this is already I told no. This is threshold limit. So we after we getting the summation, based on the summation we compare to the threshold limit. That threshold limit is greater than or equal to summation of value that represent as 1. If it less than or equal to 0, that is represent as 0. See, this is a perceptron, training up perceptron. See, X is training of a set S of example x comma t. X is a input vector, t is a desired target vector. Example. So this is a iterative process. I will tell you later perceptron clearly. Yeah, here see, for example, we will give the input x1 x2 x3 input values, and w1 w2 w3 so on, that is a weighted values. So we calculate in summation of values. So after summation of values, that find out the compare with the threshold value. Based on we comparing the summation value, a value and theta value, we based on the we comparing that value, we classification 0 or 1, so that we do the iteration process. So when if it is y it is not reaching the target value, then we will go for iteration process. W not equal to w plus a into t minus y x into that. It continues, we have to iterate in the process up to t equal to y equal to t, means target it is reaching the target value. This is a perceptron training algorithm. So architecture of perceptron algorithm. So this is we calculating the error value. I will tell you in propagation, back propagation algorithms. I will tell you later this one. Okay. See, perceptron algorithm works only for linear separability. See, already I told no. So linear separability only we can applicable perceptron algorithms. That one only AND operation. logical or exclusive OR, we unable to apply the perceptron algorithms. See here green green is one side and red is one side, so it is linear separability. We can able to separate to the red is one side and green is one side, or also we can do the green is one side and or is one side. Exclusive OR we unable to divide the linear separability. Back propagation algorithm. See, back propagation is an example of supervised learning is used to each layer to minimize the error between the layer of response and the actual data. The error at each hidden layer average of the evaluate error. See, back propagation error means, see, input layer, for example, target value and actual value. See, target value is 5, so I have received 4. I getting the actual value is 4, means we did not reach the target value. Then we have to find out the error value. Then based on the error value, we have to update in the weights of the each layer, so each input. Then that one we have to do hidden layer and input layer both. After we update the weights, then we can go for feed forward network. See, back propagation learning randomly assign the weights 0 or 1, present the inputs from training data, propagate to output, compute the output O, adjust the weights according to the delta rule. Back propagation, the errors, the weights will be closer, so that one networks learns to the desired output. See, already I told, no, so if we target value it is not reached to actual value, then we have to update the weights in the hidden layer and input layer. See, back propagation very powerful, can learn any function given the enough hidden units. With the enough hidden units we can generate the any functions. Have some problems of the generalization and memorization. With too many units we will end to memorize to input and not generalize the well. So networks require extensive training and many parameters to fill with and can be extremely slow to train. See, this is sample data set x1 x2. This is the input, this target value, this is a target value. And then we can calculate the see here these are 0.4 and minus 0.7 input values. These 0.2 and 0.1, 0.2 is a weights. So then we have to find out the a value, this one 0.1. A value is output of x1 equal to input of hidden layer. So 0.1, 0.2 is the input of hidden layer, so that we can find out update the inputs and weights. Then we can find out the output value. So what I have to told, no, see, two things. One is perceptron algorithm. Perceptron algorithm means, see, input values and weighted values. Both values we have. That one we can find out the first we can check the we receiving the target value or not. If we not, then we can find out the a value, that a value we can compare with threshold value. If your threshold value is equal to greater than or equal to a value, then that is represented as 1. If you a value is less than or equal to threshold value, that represent as 0. That is a perceptron. So next to back propagation means we can go for feed forward algorithm, but we can find out the error. So actual value, target value, and actual value, that based on the actual value target, we can find out the error. That error we can update the weights from hidden layer and input layer. Then after that we can go for feed forward network. Then we will get the we will reach the target value and equal to actual value. Next, I will go for probabilistic neural networks. So these having 4 layers: input layer and hidden layer, pattern layer, and output layer. The architecture of PNN: output layer and simulation layer, pattern layer, and input layer. See, input layer means it supplies input to the hidden layer, extract the feature from the data set are supplied here. Hidden layer. See, hidden layer means there are total and neurons in hidden layer. There are graphed based on the corresponding the classes. So if there are C classes in neurons, each group, they will be n by C neurons. Output X at each neuron will be computed by the probability density function. The generally based on Gaussian distribution. PNN architecture details. See, pattern layer and all these neurons which belongs to that classes will be summation of here. So the output layer it decide in which classes test sample belongs to the compared F values of the pattern layers. Advantages of using the PNN. See, advantages: fast training the process and guaranteed to coverage to optimal classifier. The size of representative training set increases. Training samples can be added or moved to the without extensive retraining. Disadvantages: large memory requirements. It is a vital to find accurate some smoothing parameter. So application of PNN. The probabilistic neural networks in modeling structure of the storm water pipes. The neural networks, probabilistic neural networks in solving the different pattern classification of problem. Application of probabilistic neural networks to population of pharmacokinetics. Probabilistic neural networks to the classify prediction of leukemia and embryonic tumor of central neural systems. Probabilistic neural networks is a character recognizing. Example of PNN. Let we have 2D data set consists of 2 different classes represented by the different patterns, pi and summation. Samples belongs to pi 5 comma 1 comma 5 3 comma 2. Sample belongs to class 7 8 comma 6 9 comma 5. Let smoothing parameter. See, this is a PNN networks details: x1 and x2 input layer, g of x1, g of x2, g of x3 and x3. These are coming to the hidden layer. Summation of layer, f of x equal f of and f of to x2, and decision layer means output layer. See, we have calculation of the hidden layer. These are we have to use the formulas. These convolution. Next, I will discuss about convolution neural networks. See, convolution neural networks, we have reduced 3 parameters. One feature is sparse interactions, and next is a parameter sharing, and next is the equivalent representation. See, if sparse interaction means, for example, feed forward networks, every input is connecting the hidden layer. Each input layer connecting to the every hidden layer. So that we can use the sparse interactions. So next we can discuss parameter sharing. See, these images we can divide it to the we can take the filter. Each filter we can divide it to the pixels, so that each pixel we can find out we can apply the activation function, then we can find out the values. See, equivalent representation. See, for example, we have to give this image g of f of x by g of x equal to g of function into f of x. See, convolution neural networks, we have 3 layers. See, one is convolution layer, activation layer, and pooling layer, fully connected layer. See, we will discuss about one by one. Convolution layer. Steps involve convolution layer. First, we line up the feature. See, we have to take image. That image we can divide it the pixels. Okay, filters. We can divide it the pixels. That we can divide multiple each image pixel by corresponding the future pixel. So third step is add them up and divided by the total number of pixel in the future. See, this is for example, I will take the image is x equal x as taken the image, so that one we can take a one filter. See, this is a one already this represent as a red color, that is a filter. That see there these are small pieces of bigger image. We choose the feature and put it on the input image. If it is matches, then matches is classified correctly. See, each filter we can divide it a pixel. That pixel we can multiply the multiplication of the that one. See, 1 into 1 1 then plus next minus 1 into minus 1, then 1. That one I will divide multiplication of the each pixel value, then divided by total number of pixel. See, 3 into 3 means 9, so equal to 1. So that one I will represent is like this 1. So like this I have to do every filter. See, earlier I will take in the here up filter, then I will go for middle filter. See, same thing, middle filter also that one multiplication of the pixels 1 into 1 and minus 1, same that we can calculate 0.5. So like this every filter we represent pixels. The each pixel we can multiplication of the values, that that is summation of the total number of pixels. See, now we using same picture, move it to another location, perform the filter again, same. See, earlier we done the up filter and then middle filter we can done that. We can do the every filter for enter the x value. So then see, here we can find out the value. See, upper value, upper filter we can find out the value equal to 1 divided by 9 equal to 1. So middle filter we can find out the 0.5. So like this we can represent here. See, one is a upper filter and 0.055 is a middle filter. So that is we have to do the convolution layer. That see, each filter we have to cover whole image, means x we have to cover x image. Activation layer. See, convolution layer, first we can take images. That images we can divide it the filter. That filter we can divide it the pixel. Each pixel we can find out the values. That values we can represent as like this. Then after we creating this matrix, then we can go for activation layer. So activation layer we can apply the activation function here. So non-linear activation function for learning, a1 into a2 into x equal to a1 into a2 x equal to a into x. So here ReLU function we can use it here, activation function, ReLU function. So here ReLU layer, this layer we remove every negative values from filter images and replace with zeros. See, for example, if you have see, we can find out the values like this. See, 1 minute, here 1 and 0.55, these like this, we each filters we can find out the values, we can fill in the all matrix. Then after, then we go for ReLU function. In this ReLU function, if you have minus value means less than 0, then that is represent as 0. If you greater than 0, then whatever value is then that one we can represent. If you 3, then we can represent 3. If you 5, then we can represent 5. See, here we can we can understand easily. See, here 0.077 means if we, that is 0.77. So see, minus of 0.11, that is a less than of 0, then that represent as like 0. So that we can do all pixel. This is for only one filter. We have to do whatever all filters based on the images. So pooling layer. See, after we getting the this one feature for one filter, then we can go for pooling layer. What then I will tell you. In this layer, we string the image stack into the smaller size. See, for example, we have 9 to 9 matrix, then we can go for 3 to 3 to 3 to 3 matrix or 4 to 4 matrix. So what we do now, see, for example, we got here this is a one feature for one pixel, right? One filter, right? Then these I will take this one.
Ramesh sir,
Sir. Yeah.
full screen mode lo పెట్టవా? కొంచెం screen size పెంచరా? Keep in full screen mode.
Oh, sorry.
No problem, carry on.
Yeah, one. See, here we can find out. See, this one we can output of the one feature, and see, we can let's start with our first filter image. In our first window, we maximum highlight value is 1. See, we can take the 2 by 2. So here 0.77 and 0, 0 and 1. So here we can take the highest value. See, highest value is 1. Then we can take here 1. So like this, we have to do all filter, all pixel. So like this, we can next we can take a another 0.11, 0.33, 0, 0.3. Here it is highest value is 0.33. Next we can take 0.55, 0, 0 and 0, 11. Then that is highest value 0.5. Like this we can represent like this is a 9 by this how much. This is 10 by 7 matrix, then we can represent as like this 4 by 4 matrix. See, this, see, first we can first we can take the image. That image is a x. That image we can take convolution layer. That convolution layer we can divide it filter. That each filter we can divide it the pixel. That pixel we can multiply the pixel by pixel into plus adding them and total number of pixel. That we can value, we find out that value. That after that value we can apply the ReLU activation function. ReLU activation function means if you minus value, if you minus value, negative value, we can represent as 0. If you greater than 0, then we can represent same value. Then we will go for pooling value. Pooling value means if you have bigger matrix, then we can minimize the reduce the matrix value. So like we can represent like this. So after fully connected layer means this is final layer of actual classification happen. So see, this is see here 1 0.55 0.5511. Then this is we can we can take the single list. So here one this is the output. See, I will give one example. See, output of the when we feed x and o, then there will some element in the vector that will be high. See, x equal to, what is the x value means? See, 1 1 and 2 3 1 2 1 4 5 and 1 2 3 4 1 4 5 I think 9 10 that represent as x. And 1 2 3 4 5 2 3 and 9 10 11 12 that represent as 0. So this is we can classify the data. So based on the layers, convolution layer, ReLU function and pooling layer, then we have trained the data. So after training data, then we classify in the like this. See, 1 4 5 and I think 9 10 that represent as x. Then here 2 3 and 9 11 that represent as like this 0 o. So here I have to give this input image, this one. So we have trained data, and then I have to give the input image. So I have to calculate given input x or o. That how we can compare. See, this is a x input image. So input image, what I told. See, one, we can take the one value and 1 2 3 fourth value and fifth value, 6 7 8 9 10th value and 11th value. So we have take some of the this one value, fourth value, and that we can calculate the 4.56. Here vector of x, that sum equal to 5. So this is 0.91 divided by 0.91. So next this is compared to a vector of x. Then next I will compare to vector of o. So here we taking sum equal to earlier I told no o value. Here 2 3 2 value and third value and third 4 5 6 7 8 value, 9 10 11 value. So we can calculate that value. So in sum equal to 2.07. so here then vector of o sum equal to 4, that one divided equal 0.5. so if you, it is value is equal to here highest value is equal to 0.9. so the input value is reaching to the x value. So input value equal to output result equal to x. So that we can do like this. So I will tell you recap again. CNN layer means four layers. One is a convolution layer and activation layer and pooling layer, fully connected layer. See, convolution layer means first we can take image. That image we can divide it the filters. That filters we can take in the pixels. That each pixel we can multiply the each pixel by the corresponding the future pixel. That one multiplying the value, adding them and divided by the total number of pixel, divided the total number of pixel. See, this is filters. This is the, here see red color one filter and green one filter. All these filters, this is multiplication of the each filter, each pixel, and adding them and divided by 9. So that we can calculate value. This here middle filter we can calculate the value equal to 0.55. So like this we can represent like this. Then after that find out the matrix. Then we can apply the activation layer. So activation layer we can give the, if you less than negative value then we can give 0. If you greater than value then we can give same value. That we can apply in ReLU activation function. Like this we can find out the activation. Then after we minimize the matrix, then we can take in window 2 or 3. Then we can take window 2 by 2 matrix. Then if you compare the 2 by 2 matrix, if it greater than greater value, then we will take that value, can represent as 1. So that we can done the pooling layer. So after pooling layer, we that one input we can take a single list layer. So after single list we can represent like this. So x is we classify the like this to 1 position and 4th position, 5th position, and 0 as represent as like this. So if you given after we have train data and classification data, then given input is it is belongs to x or 0, then we can find out like this. See, we can find out sum and input image, and we can find out sum of the vector of x, divided them, and here input image, sum of this input image and vector of the sum of the vector of O image. So we can compare. If you greater than compare values, if you highest values we can take in. So if your highest value is 0.91, that is called x value. So this is the thing we covered. See, perceptron and back propagation, PNN and CNN. Perceptron means we have input layer, hidden layer, and output layer. Input layer we can apply the input, and we apply the weights. We can calculate the A value compared to the threshold limit. Here perceptron we don't have any activation function. We have to compare only threshold value. That threshold value is greater than or equal to threshold value, then that is one classify the 1. If you less than, then that is one classify the 0. So that is a perceptron algorithm. Back propagation algorithm, it is a feed forward network, but we can find out here find out error value. So we can find out the error value. Based on the error value, we have to update the weights to the hidden layer and input layer. After that we go for same feed forward network. So after that, convolution layer. See, convolution layer means already I told no, convolution layer and ReLU function, pooling layer and fully connected layer. So then I will show one. See, this is a transfer flow playground. See, this is a data set. These are data set. So I will take in this data set. This is the input layer x1 and x2. If you want more inputs, then we can add it like this. So these are inputs, and so these are hidden layer. If you want more neurons, then we can apply, like if you click on this one, we can add it. Otherwise in hidden layer, if you want more hidden layers, then one more hidden layer we can. So this is a hidden layer, and this is a output. So if you want activation function, we have to apply ReLU or tan, sigma, linear. So based on we can apply this activation function. Data is data set is classify the data. See, we have two orange and green color. So we have applied the linear function. I have inputs x1 and x2 and x1 square. These I have two hidden layers. So I will increase this one. So I will apply the activation function. See, like this. It is a classification of the data. So after applying the neural networks, data is classified like this. So if you we apply the ReLU function, it is classified in the like this. If we go for regression, see, like this. This is orange is one side and green is one side. This is a for example, practical example. So this is we can use easily understanding for neural networks. Then next thing I will tell you Python. So we will take a data set, then we can apply the activation function. Then how we can whether it is classification is correct or not, that we can show the in Python. So see, in Python we can use Anaconda Python 3.6. See here, we can click on this one, individual edition. Then we can go for down. Here, Python 64. If you have OS is 64-bit, then we can download for 64-bit. If you 32-bit, then we can choose for 32-bit. So we can click on 64, then we can download it. Then click on next. Then it is automatically installed and Python. Then after that, we can able to see here Anaconda. So here we can click on Anaconda Navigator. Here it is Anaconda Navigator. Then we can use Spider or Jupyter. Then we click on launch Jupyter. See, it already has one program. I will explain the one program. See, see, this is a program. See, before I explain the program, I will tell you Iris dataset. So these we can dataset we can find out. See, this one here. UCA machine learning repository. We can find out the data sets. Lot of data, whatever you want, then we can download the data set, then we can apply the classifiers and optimization algorithms. So here I'm using the Iris data set, this one. This is I'm using the Iris data set. Then see here I'm using the Iris data set. So here Python program. So here we can use some library functions. See, we can import the activation function, logistic regression function. So some the classification report, some library function. We importing the library functions. Then we here iris data set. So here we can display the head of the data, spell length, spell width, petal length, and petal width. So this is types of the classification. Classification. I will open the that data set 1 minute. See, this is a data set. So here classified Setosa and versicolor and Virginica. So here three classification: Virginica and versicolor and Setosa. So these are three classifications. See here we noted on data head. We can display the columns of the data set. So here we plot relation each. See, species. We can apply the some features. We can apply the features. We apply the colors. So here spatial length equal to blue color and spatial width equal to green color, petal length equal to red color, so petal width equal to black color. So these we can represent x-axis, y-axis. Spices is a y-axis, future is a x-axis. So x we can apply the train the data and test the data. So split into the 8% training and 20% test. So here we can and train the data. See, we x train and x test, y train and y test. So here we can we applying the logistic function. So logistic function. So logistic function. Then we can find out the prediction. See, print classification of report. We whatever our classification based in precision and recall. So here three types of classification: Virginica, versicolor. This three types of classification. We can precision is 1 recall is 1 So this we can see Python program. Say like this, we can download the data from this website. Then we can apply the classification. We can use a lot of classification is there. We can apply the classification. After applying the classification, then we can go for optimization techniques. So then if you earlier in existing paper, if you have some optimization is a 0.9, then you can apply the another optimization technique. You can give 0.6, then that you good optimization, then that you can go for paper, it will be published. So like this we can go for, first we can creating the we can take live data, or if you go for this data this website, then we can find out the data set. That data set we can apply in the classifiers. So using, or if you can use an MATLAB or Python, apply in the classifiers. After that classifiers, if you have to apply the optimization. So this, if you see my work is neural network, sorry, brain computer interfaces. So I'm using the live data. So live data mean see light detection. See light detection. I'm using the live data means I'm whoever I will take a one person. I will keep a machine in brain. Then I will capture the data from amplifiers. So if you some person is crying and expressions, that all data I will collecting the live data. So that if you go for live data, it will take lot of time. If you using old data, then you can go for this website. You can getting lot of data sets. If you go for live data, it will take lot of time to getting live data. If you go for another research, cancer and diabetes, if you go for cancer data set, means if you live data, you have to go for hospitals and get data from hospitals, that live data also. So I'm preparing the live data, live detection. So these are my live data. I'm not using any website. I'm capturing the data for the, brain computer interface mission. So after that, I'm applying the classification. After that, optimization technique as well as fuzzy techniques. These we have to go for deep learning and neural networks. These students, we do first we have to collecting the data. After that, we have to classify in the data. Then after that, we have to apply in the optimization techniques. That is we smoothly for it is paper will be publishing this smoothly. So for it is helping for MTech students or teachers. These our side. Revati madam, this is completed from my side, Revati madam. Hello.
Sir.
Yeah. This is our end, madam.
Yes.
This neural. Yeah.
So yeah, anybody have any queries? We'll let you know, sir. So we'll give time for the participants
Okay, madam.
to have any queries. They'll ask, sir.
Sir, I have one question.
Yeah.
Sir, how to get the target variable? Sir, what is the procedure?
Yeah, sir.
How to get the target variable?
Target variable.
Yes, sir.
From which you are talking about? Which one? Convolution layer or? Hello.
Yes, sir. In the slide only, we have seen somewhere target variable was there. Before this, I think, sir. Still, you have to go back, sir. Yes, sir. In the perceptron only, it will come back.
Yeah.
Come back, sir. Still, you have to go back. Still, you have to go back, sir. Yes, sir. Here, sir.
Yeah. This is one example. Target value. See, for example, I will tell target value equal to 5. We have to given. I'm telling the example.
Yes, sir.
X1, X2 input value. See,
Yes, sir.
target value equal to 5. I will actual value I got is a 5. That is
Okay.
it. We are not reaching the target value. That we can at that time we can find out the error. Then based on the error we can updating the weights, so that we can done the hidden layer and input layer. This is actually here one example is there. So if you I deleted that example. That's why the one slide is I kept here. That's
Oh, okay, sir. Sir, in case of label data set, can we find
hello.
by looking at the data set,
Sir.
can we say it is a target variable column?
Hello.
Yes, sir. Is it possible to
Revati,
say?
is there any questions, Revati?
Sir, he's asking.
Revati, madam.
Sir, am I audible, sir?
Sir, he's asking the question. One of the participant is asking the question, sir. Are you able to listen, sir, his question?
Sir, am I audible to you?
Ramesh, sir.
Hello, sir.
Hello.
Ramesh,
Yeah,
sir, am I
Ramesh.
audible to you?
Hello.
Hello, sir. Am
Ramesh,
I
sir.
audible to you? Hello, sir.
Yeah, Ramesh, sir will join in soon. Maybe there's a problem at his end only. 1 second, sir. We'll wait. I think he has left the meeting and he will rejoin.
Okay, okay.
Yeah, Ramesh, sir will join in soon. He's joining the session. Meanwhile, I request all the participants to fill the attendance come feedback form for the afternoon session. Just now we have forwarded the link in the Meet for the afternoon session. So if you have any queries, you can also text the query in the chat window.
Yeah, you can ask the queries. Any user interface programming for Python. Please suggest any user interface. Okay, all Python editors, all Python IDEs are user interface. Python itself is a simple language to learn. Spider, Jupyter, or even Google Colab that helps you to learn the programming through user interface mode. Once you have IDEs or notebooks, there are many online tools that helps you to learn, like Geeks for Geeks, W3 Schools, and many online platforms are there to learn the Python. If you want to be browser based, then Colab is enough. If you want to be IDE based, you go for Spider or PyCharm. Even Jupyter helps you as the dynamic storage capability. వినిపిస్తుందా?
Hello.
Sir.
Sir, can you hear me?
Yes, audible, sir. Please go on.
Yeah, actually,
Srihari.
yes, Srihari here. Actually, I want to know about how can we implement it in user interface. I mean, can we use it as a web application? Shall we create any user interface applications using Python?
Okay, web application.
Yeah. For example, so Python is Python. It is a language, okay. But if I want to apply for any user interface, if I want to implement it for a user interface applications, then how can I use it?
For user interface, you need to learn about first of all basic coding in programming, sir, using Python. Later, in Python there are visualization libraries.
Yes. Yeah.
Visualization libraries, and there are libraries which are able to connect the database with the front end.
Okay.
Yeah, using these modules, you need to integrate 4 to 5 libraries. Okay.
Okay.
We need to integrate those libraries with them. We could develop user interface module using Python.
Okay.
I'm sending the stuff related to that.
Okay. So, for example, GUIs are there, right? Teak, Inter, PyQt, WX, Python, Remy, like that.
For what type of web application you want to develop it? I mean,
So,
requirement, I will tell you the libraries of Python.
yes. For example, I want to use, for example, I am a research scholar. Okay. So I want to uh, run some proposed algorithm, security algorithm. Okay. So I can use Python code for writing security algorithm. But if I want to implement in GUI, then how can I? For example, if I want to upload some of the files, so how much time it has taken to upload and downloading? So I want to calculate like that. So every time I need to put URL in the Python code. I have to run. I have to get the result. Uh, it is not suitable, I think so. So that if I create an application, so I can directly upload the file and I can get the result. What is the downloading time? What is the uploading time? Okay, so like that, to encryption and decryption the file. So I have to use an application using Python code. So that is I am asking from you.
Okay. First, so the first step we need to knowing the type of interface you have, declaring the interface. Okay.
Yeah.
Then for implementing the interface.
Yes.
Right. Then after that, what are the methods we need for them? Like implemented by class, by object, and you want to implement with the help of job, the form of zipper folder, or plain text as it is, or plain file as it is.
Yes.
These are the modules. After that, if you want to use the usability of the framework what we have, and we go for interface inheritance.
Okay.
Yeah, these are the 4 modules available to go for Python interface modules. I'm sending the stuff related to that. This is the URL. Their main modules and the basic procedure is defined here.
Okay. Yeah, fine, sir. I will grow. I will go through with this one. I will check. Thank you.
Thank you.
Sir, one more, Srinivas, sir. Could you suggest any websites which will get Python hands-on with more number of programming exercises?
Python platform for
Asking for, yeah. Could you suggest any websites, which will get Python hands-on with more number of programming exercises?
okay. There are many number of platforms to learn the Python, but the context is you have to specify the type of exercises you want to do, the type of programming. Whether you are focusing on the machine learning, are you focusing on the data science, are you focusing on the artificial intelligence related module, are you focusing on the array matrix implementation? Python have or you want to work out with the image analysis, image processing, or image recognition. So based on the type of the requirement, we have the different platforms to learn the Python. For the conventional or basic level of learning, as I told you, the platforms are if you do work with IDE, Spider IDE, or browser-based URL, we need Google Colab. These are the platforms. But learning platforms are where you will get the basic stuff, explanation, and little bit code fragmentation. There we have to be accessed through W3 schools or Geeks for Geeks. These are the URLs where you get the basic content.
Yes, sir. Thank you. And one more, Mr. Shivaprasad, sir, raised the hand. Sir, yeah. You have any query to pose? Shivaprasad, sir? No? Okay.
Between between R and Python, the Python gives you the more scope to visualize, to interfere, and to customize the code compared to R language and Python, sir. You have the more scope to exercise, to customize, and to refine your algorithm of machine learning compared to R. Python is better, where you can do the more exercises, whereas in R you have the little scope to customize your requirement. The coding part is less in R, as it is a predefined function. Okay, for agriculture data analytics using machine learning approaches, is Python or R language is required? Agriculture data analytics using machine learning approaches, is Python or R language? Okay. If you are asking about programming, or if you are asking about experimentation, then Python is better. If you are asking about analytics in terms of based on your objective, the analytics is determined. What you want to analyze, right? Analytics normally comprises with analysis, which is the subpart of data science. So for generating the output, the Python with machine learning or Python with deep learning technique is suitable. For analysis part, analysis in terms of visualization, Matplotlib available with the Python is better. Analysis with other type of modes like graphical representations, bar charts, and other visualization, then R is better.
Sir, which version of Python is better suitable for TensorFlow?
Which version?
Which version of Python is better for installing TensorFlow?
3.8.1.
3.8, right?
Sir, namaste. This is Anand Narayan speaking from Hyderabad, sir. Sir, in stock price prediction, sir, my question is very focused on stock price prediction, sir. In stock price prediction, using deep learning algorithms, particularly with artificial neural networks, sir. In artificial neural networks, sir, which based algorithm means convolution neural networks, recurrent neural networks, probability neural networks like that. In all of them, which one will give prediction accuracy more percentage, sir?
Recurrent neural networks.
Yes, sir. Thank you, sir.
Yeah.
Any more questions from the participant side? Any more questions you have? Srinivaslu sir, Jayanarayan sir is asking you to suggest some Python sites for machine learning.
Just now I messaged it. The URL that helps you from the beginning. There you can find the tutorials. There you can find the explanation stuff, and little bit code segments also available. Any more?
Yeah, asking for suggesting some books for machine learning and deep learning. Yes, you're asking.
For machine learning, Tom Mitchell. Tom Mitchell. For ML, Tom Mitchell. For DL, Aurelius Publications. Deep Learning Practice Guide by Aureli Publications. Let me give you the other stuff.
Okay, thank you, sir. We'll conclude. So I request all the participants to fill the attendance and feedback form. Shall we conclude, sir? Yes.
Yeah.
Thank you to Mr. M. Ramesh, software developer from TCS Hyderabad, for delivering this talk. Thank you once again to him for his insightfulness talk about neural networks. Tomorrow we have the session on exploring a CNN for real-time practices, essentials of deep learning and application, deep learning for face recognition. These talks will be given by Ramalinga Swami sir, Kavya madam, and Mukesh sir. So that's about the today's session. I request all the participants to fill the attendance and feedback form. We have already forwarded in the Meet and YouTube link. If then, yes, you can leave the meeting. Thank you. Thank you once again for all the participants for your active participation for today.
Hello, ma'am.
Revati ma'am.
Madam.
Revati ma'am is here.
Yeah, I'm here. Tell me.
Ma'am, Priya from CIT. I was able to join the session only in the afternoon. I didn't know my ID to fill in the feedback form.
Just
So
now, just now we have forwarded in the group, ma'am. Participant list PDF document just now we have forwarded. In the attachment, you can find out your ID. I think so. Your ID is 4. 1 second, I'll tell you.
Yeah. I think I have submitted the form.
Wait, ma'am. Your N Priya.
Yes, ma'am.
Yeah, 455, madam.
455. Okay.
Yeah, 455.
I was not able to come back to meet without filling that, so I just gave a submit option. So
Okay.
and tomorrow onwards, I'll give the correct ID, ma'am. I think today it will be submitted without the ID. The last 3
Yes.
numbers I have not marked.
Okay. I'll check, ma'am.
Okay.
Madam, could you please share the morning's feedback, ma'am?
Morning. Okay. Okay, sir.
Because due to network issues, I joined lately through YouTube, ma'am.
Okay, you're Gayatri, madam.
Yes, madam.
Yeah, okay. 1 second, I'll share.
Okay.
I saw your message, but if I send that link, maybe participants will get. They won't check whether it is morning and afternoon. No, so I'm
Yes,
just waiting to forward. Yes, now I'll for because only 34 are there.
Yes, ma'am. Yes, ma'am. Please,
I
ma'am.
sent that is a morning one.
Thank you so much, ma'am. Yes, ma'am.
Yeah.
Thank you, ma'am. Right.
Revati ma'am, should I fill the morning session too?
Yeah, you can, ma'am, because the form is open. So any participants, if you don't fill the morning attendance form, you can do it now. The form is open still. Morning and afternoon attendance both are opened.
Yeah, thank
Madam,
you.
afternoon session feedback, ma'am.
Afternoon. Yes, sir. Posted.
Thank you, ma'am.
Okay. Good morning to all the participants. A very warm welcome from the Department of Information Technology, VNR VGIT, to all who are attending this short-term training program on machine learning and deep learning techniques for artificial intelligence problems using Python. And this is series 2 session, so which is going to start from today onwards, 14th to 19th December. And this is a STTP which intends to conduct faculty training.
The advances of AI to another level. So AI will tells you the problem to be solved. ML will identify the algorithm to learn from experience, and if you want to be more precise in an outcome, then the deep learning is required, as deep learning is simulating the functionality of the brain. It is simulating the capabilities of human by identifying the patterns, by identifying the complex issues, and coming out the labeling or coming with the conclusions. As human beings have the great capabilities of instant responding, instant interpretation, dynamic in nature, intelligence, thinking, organization, knowledge management, reasoning. These are the great capabilities of human being. And the same capabilities I need with the computer system. The systems or the computers can do the things based on the instructions given by us to do so. The computers are there to do the activities based on programs given by us to perform a particular task. That's all. They don't have the common sense. 784 columns. Each picture has transformed into a feature vector. Based on feature vector, the label tells the computer what object is in the too much training. The too much training goes to or yields to overfitting. I told you the confusion matter.
Analyst, and he's having 9
on the actual weight target. We can find out the error. That error we can update the weights from hidden layer and input layer. Then after that we can go for feed forward network. Then we will get the we will reach the target value and equal to actual value. Next, I will go for probabilistic neural networks. So these having 4 layers: input layer and hidden layer, pattern layer, and output layer. The architecture of PNN: output layer and simulation layer, pattern layer, and input layer. See, input layer means it supplies input to the hidden layer, extract the feature from the data set are supplied here. Hidden layer. See, hidden layer means there are two here classified.
Sir,
On the error, we can updating the
our user interface. Python is
to given. I'm telling the example.
Yes, sir.
X1, X2 input value. See,
Yes, sir.
target value equal to 5. Actual value I got is a 5. That is
Okay.
that we are not reaching the target value. That we can at that time we can find out the error. Then based on the error we can updating the weights, so that we can done the hidden layer and input layer. This is actually here one example is there. So if you I deleted that example. That's why the one slide is I kept here. That's why.
Oh, okay, sir. Sir, in case of label data set, can we find by looking at the data set, can we say it is a target variable column?
Hello.
Yes, sir. Is it possible to
Revati,
say?
is there any questions, Revati?
Sir, he's asking.
Revati, madam.
Sir, am I audible, sir?
Sir, he's asking the question. One of the participants is asking the question, sir. Are you able to listen, sir, his question?
Sir, am I audible to you?
Ramesh, sir.
Hello, sir.
Hello.
Ramesh,
Yeah,
sir, am I
Ramesh.
audible to you?
Hello.
Hello, sir. Am
Ramesh,
I
sir.
audible to you? Hello, sir.
Yeah, Ramesh, sir will join in soon. Maybe there's a problem at his end only. 1 second, sir. We'll wait. I think he has left the meeting and he will rejoin.
Okay, okay.
Implement analysis.
Give the if you
Analyst, and he's having 9 years of experience